Let's see here. Is it working? Can people see this?
See it?
Oh. Okay. Do this. Stream number 4 and read in frames. Check CRC. Maybe send something. Okay. I guess it's about time to start. I mean, like, I guess I'm streaming right now. Let's see, who all is watching? How many people? That's weird. I don't have any stream activity. What is the...
I saw 8 before I rebooted.
Oh, that's weird. It was at like 11 waiting, and then... Huh. Well,
2 of them were me, probably.
Maybe people are learning that these streams are boring.
Oh!
Anyway, let's see here. I think that's it. So my goal for the first minute here will be to say what happened, go over the diffs, and say what happened, then say what we will do on the stream, and then go over the diffs since last stream, because I did some off-screen mining. I'm not really sure why. I don't have a concurrent view count here, but I'm going to just assume things are fine. Yeah, I mean, I guess we don't really need to do ping or anything. All right, everyone, thanks for coming out to stream number 4. Last stream we ended up with me trying to fight over getting exactly the right number of cycles for all of the operations we needed inside of our receiving loop for USB. That didn't work out because we succeeded, and then we found out the bits were backwards going into the words and that we needed to put them in the other way. LSB first, which means shifting a word down instead of up, and well, that meant it so that it was a lot harder to put the words in. So what I did in my off time was I switched 2 things. One is I made a PWM for debug output so that I could look at my debug loop as I was going. I also made it so that, I changed the way I do debug output. So instead of writing like low, high, low, which takes 4 cycles, I made it so I can just update timer 1 CNT, and that creates a single pulse. And one of the other nice things about that is that single pulse appears in the middle of a clock, which makes it a lot easier to do clock timing instead of trying to remember like which edge you're on. The key was to stop trying to chase a branchless approach. So I added a branch, made both sides equal, everything worked out. It was really easy. It was like all of like 20 minutes once I added that. And I added a pre-loop thing for getting the message type. And then for this stream, what we're going to be doing is we're going to be reading in those frames. We're going to be passing them off to C space, though we might dial that back a little bit. We might do some of the handling and assembly just out of convenience. Then we're going to be checking the CRC, making sure that our CRCs are correct. And then we might try sending something back to the host. This is like our stretch goal for this stream. Will we succeed in that? Almost certainly not, but let's just hope for the best, and when we don't get it, it's gonna be okay. I guess what I really want to do is I want to go over the diff, and then I want to show what that looks like with the new way of doing the debug things. So the diff, oh, not here, get K. What I actually want to do is diff to this. Git diff. I wish I could store this. So. Okay. Oh, Axel Crusher, just FYI, this Discord call here is on the live stream. So you can say hi, because there's not that many people looking. But just FYI, anything you say is on YouTube. I'll take that as not saying anything. Anyway, so the diff between yesterday and today was I moved a bunch of things out, like the knobs around, just to make things line up better. And here is kind of the first big one. I made a packet type loop, so there's no CRC being performed here. And we also don't have to handle the case for if we have to bit stuff, because there's never any bit stuffing in the packet types. And this packet type loop basically just goes really fast, reads and 8 bits. Then we can decide what we want to do with them. Something, we'll figure that out in this stream. And then it goes into the other loop. So the other loop used to try to go straight through and it was unrolled, but now what it is there is a jump. So if the bit is a 0, then it jumps to handle 0 bit. Otherwise it handles 1 bit. And the nice thing about that is you don't have to worry about trying to like shift bits around in really bizarre ways to make everything line up. I can just say set it to 1, then shift it by 7. And really basic things like that, instead of having to handle like weird or and cases to try to make everything line up. Who knew? We should probably have just used a branch. And that's pretty much all I did, I think. Yeah, so all this code down here is just to make it so that the pulse works the way that I had it set up before. So I guess I'll show you guys that right now. So I'm going to say make clean all monitor. And over here on the Sele side, I'm going to have to unplug it, replug it.
Just a quick thing if we're...
Whew.
Just a quick thing if we're ever sort of starved for cycles again. You can always change handle CRC and sort of hard code it for the 0 and 1 bit cases.
Yes, that's actually what I did in this. Here, I should bring up the code as it stands right now. So if I look in rv32 blah 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 .s in here for the CRC code, let's scroll down to handle 1 bit and handle 0 bit. For the CRCs, oh wait a minute, am I not handling the CRC? I might not be handling the CRC in this code. Am I? Did I just maybe? I mean, I was doing this at like 4 a.m., so I could have just completely forgotten what I was doing.
Well, I see 2 handle CRC macro calls there. But what I was saying is more just like...
Oh yeah, here, yeah, handle CRC.
Yeah, I'm saying you can totally... So, I mean, we still have a bunch of magic in there to coax it into working with both 0 and 1 bits, right? And so you can get rid of probably all of that and have maybe 3 instructions per side.
Actually, you know what's really depressing is I didn't update this code, so the CRC stuff is probably still super wrong. Like, I'm going to have to go back and revisit that and like rewrite some of the CRC code. But the point is that I had a lot more free time when I decided to go like, okay, we'll handle the 1-bit case and we'll handle the 0-bit case. And that just made everything line up way easier. So let's see. Somewhere here. Let's zoom in here. So... well, that's concerning. Did the wire fall off? No. Why is that not right? Let's try this again. Uh-oh. Well, that's not good. There should be bits going high and low here. We should try to fix that. Why is that not working? Always marching forward and sometimes twirling. And yes, is cool, same thing. And the goal, though, is to all of this, get USB running on this part. So until we get USB running on this part, I'm going to keep trying, or I'm just going to give up and, like, just go in a corner and cry. Let's see here. So it's using OC to temp2. Let's see here. T1C3, T1C3, and that's port C3. Am I plugged into port C3? I am plugged into port C3. Oh, I see. It's on the next channel down. That was what I was forgetting. Channel 6. I don't think we need channel 2 anymore. Okay, let's give this a shot. Ah, wonderful. Okay. So what we actually have is like a tick that happens every 256 cycles, but what I now do is I now can make these things which are single ticks. And when we do our first read, the thing where we're reading to see what type it is, we have so much spare time right now that we can just go tick, 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 and it's totally fine. But what it lets us do is measure the distance between these. So between these humps here, so the blue ticks are exactly one full cycle wide, and they're nicely centered around a clock, so it's really easy to see what's going on. Thank you, is cool. I appreciate the vote of confidence there. That people will remember me for the abuse of microcontrollers that I have unearthed. Actually, let me also. Oh no, that's right. We'll be able to change the stream replay, the chat replay, which is something I do want to do. Anyway, let me try turning on this. So what we should be doing. So the idea is, with USB, when we get it, we have a preamble. We have the 1 bit, which is the end of the preamble, and then we sample a 0 bit, like right here. Give me a second here. Give me a second. Okay, so we sample the 1 bit here, the 0 bit here, the 1 bit here, and the idea is that we want to pull off the first 8 bits, and then we'll figure out something to do with it. We have all of this free time here to go just decide what it is that we want to do, and then what we're going to do is chomp on through and let this thing roll and read the data and do something with it. And then we have an end of packet, and then we can do something in C with it. And then the same thing happens for the longer packet right here, the data 0 packet, where it reads 8. And one of the nice things that we can do is we can see when is this sampling. Well, it's sampling, ooh, that's like right at the, like before it gets done. That's like at the end. And the idea is like, so we want to try to sample in roughly the same place every time. So this is actually, this particular one is going to be about a 148. Well, I don't know, maybe 1/48th of a megahertz late. Let's see, so these are, yeah, it's fine. The idea, though, is that all of our bit timing for all of the instructions that we're doing should line up so that we're sampling at exactly the right time. And this really isn't that bad, so that's pretty good. Yeah, I think this is pretty good. Okay, so let's see. What was the next thing? What is the next thing? Should I be like looking at anything with you guys before I start trudging onward? I'm trying to think here. I think that that's pretty much it. We don't know the offset from the clock to the sampling of the GPIO. That's also true, but we can experiment with it. So the idea is all we want to do is make it consistent, so it's the same distance between the clock twiddle and the sample. And then that's really all we need to do, just make sure it's the same distance every time. So if I go here, well, we do a jump and then we do the load. Does both of these end with... I think these both end with it. So what we could do is we could put the debug blip at the beginning. Yeah, let's do that. And then that way we'll know exactly that it's right after that is when it's sampling. And so that means we're probably now going to be off by a few cycles. Oh yeah, that's off by several cycles. I wish I had looked into that more sooner. Anyway, I'll show you what I just did and how that changes it. The idea is, like, I want to know right here is roughly where it's going to be sampling, is after this bit slice, but now you can see that it's off by a bunch. So it's not sampling like right after the twiddle anymore. So this is and then I sample. Here I see the blip and then I sample. So it means for this bit we're actually sampling like over here, but that's like after the bit, like towards the end of the bit. So we want to like tweak with the timing. That was a good point, that we want to yeah, I want to definitely sample like right then. Let me make sure we're doing that up here too. Yeah, and then we sample. Okay. Yeah, I think that that's good. So you see the and then a sample, and then here. So what we actually want to do is we want to cut down on these burps in the middle here. Yeah, so that's this run right here. So this run of burps right here align up to this, to this run of burps right here. And the idea is that we want to make it so that this right here is actually going to happen there. And I'm just going to eyeball it. I'm just going to see what happens if I remove 3 of the burps. Okay, let's give that a shot, and we're going to run. And it looks like we got a frame. Let's zoom out. Zoom in. Okay. So here we go. We're sampling right there. Oh yeah, that's perfect. 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 Ah, that's a little late. That's a little late too. So all these are fine, and then here. This is where the center of the byte is. I'd say that's pretty close, but maybe not perfect. That's also pretty close, but maybe not perfect. So what we can do is we can actually look at the distance between right here and here, and it says it's 33 cycles. So that means that we want to try to shave off 1 cycle from here. So I can do this, but we also need to do something else that's really annoying, which is we need to make sure that the words are still aligned. Otherwise, what I think is going to happen here, if I reseat it, oh, I gotta actually restart it. So I think this is going to be broken. And the reason I think this is going to be broken is because now the jumps, or so like where we're jumping to, the lines that we're jumping to, will not be aligned to word boundaries. And if they're not aligned to word boundaries, then what's going to happen is it's going to take extra time. So let's see, is this aligned? My theory is that this won't be aligned. So let's reset. So let's see here. So coming along, we're right here, which is a reasonable place to do it. Right here, which is a little late. That's fine. Right here, which is a reasonable place to do it. Here is early. Here is much earlier. Here is, oh, we are being late. So if I measure the distance between here and here in clock cycles, it's 42 clock cycles. Oh, no, it's supposed to be 42. Wrong thing. This is the one I wanted to measure from. This should be 64. But instead of 64, this is 66. And that's because now we've messed up the alignment of our program. So what we really want to actually do here is do a nope.l. So it's going to be a little bit longer. So if I look rvcodec.js, And we go here, and we go here. Then we type in nop. Is that not it? C.nop? Nop. Nop? Wait, what is going on? Why is that not risc-v ISA? Nop. Nop.
Oh, nop isn't actually a thing.
What do you mean nop isn't a thing?
It's I think the equivalent is like mov r. It's mvr0 or something like that. Like there's no.
It says
actual,
here.
like,
It says it's add I. Oh, nop is add I. Register 0 to register 0 amount. Okay. Well, sure. Let's. I'm gonna. Well, I mean, the point of this is I want to do add I x0 0. So it's this, whatever this is. I'm just gonna say .word. I have no idea if this is actually gonna work. Nop.long or .l. Okay, let's just see what happens if I do this. Because I am super curious if I just get lucky. Did we get it? Oh, we did get it. Okay. So now that we've been realigned, I believe this should work out. So that's going to be from here to here. 33 cycles. That's annoying. Let's see if this one to the next one is okay. "33 cycles. Wait, what? Okay, let's do this one to the next one. Surely this can't be following us. 32 cycles. Okay, so why was that 33? Oh, that's so weird. 33 cycles, though. Yeah, David Wilmore, I definitely agree. It would be really nice if we actually had a .l instruction. Sorry, to clarify, L is just something I just made up right now because I want a long instruction instead of a compressed instruction. So I just totally just made it up. So what happens if we comment this out and double this? Does that... Oh no, I clicked it again. Ah. Okay, let's give this a shot. So, between here and here, that's 33 cycles. Why is that 33? Also, this isn't even right. These words should be up here. Oh, yeah, so risc-v has a compressed instruction set where most instructions are 32-bit, but there are other instructions which are only 16-bit. Things which are like, I just want to add these two numbers together and put them back in the register which it came. Like, really simple operations are able to be compressed down to 16-bit instructions. That way your code isn't, like, really big. Okay, let me pull that up. The compressed versus regular, the reason I want that is because if I go into the listing file here, so if I look at the instruction for bit process, what I want bit process to do is line up exactly on a word boundary. Because if I don't, if this ends up at like 222 instead of 220, then what's going to happen is it's going to go way slower. So if you jump to something in between the alignment, it will just not work right. It'll be just miserably slow. Okay, I'm not really sure why these things are taking an extra 2 cycles here. I guess I'll just delete one of the knobs and hope for the best.
You could check object dump.
Say it again?
Make sure that you could check object dump.
Well, the listing is made from object dump.
Oh, you're checking. Okay, sorry. No, again, stream didn't.
Oh, okay, gotcha.
As soon as I say that.
Yeah, so it's still aligned because we're using the long ones. So if you look here, oh, that's an. Oh no, it did do it. It did do it. So if I say 1 3, it does actually do it. It recognizes that it's a knob. That's nice. So let's see here. Did me changing that fix the timing? I hope it did. Then we can move on to CRCs and start getting some of the data out. So I'm going to go just put a marker here and see, is that right? That's about right. Yeah, it's around the right time. Marker here. Yep, that looks like that's about the right time. All of these look really good. So now let's test the timing. So between the last one there and this one here, it's 31. Okay, I have no idea why. Let's not worry about that for right now. Let's measure this, and that's 33. Okay, that's fine. I don't really care. Whatever, we're off by 1 for the first 2 bits. I'm just going to ignore that. And then we're down to the 32s, which is where we want to be. That's really good. I guess the other thing I want to do is make sure that that a 0-bit and a 1-bit take the same amount of time. That's kind of important. 32. That's right. 32, that's right. 32, okay, so this is wonderful. This is still all lined up. So now we're going to want to take a gander at the CRC code. So this is a little weird. Who is it that mentioned maybe making the CRC handle the 1 and 0 branch separately? Because maybe that really is a good idea.
Yeah, I mean, on the 0 branch, if I recall correctly, it should literally just be a shift. It's either a shift and a XOR, or no, it's just a shift. And then on the 1 branch, it's a shift and a XOR. So a huge majority of the time waste before was literally just determining whether to do that XOR or not in a branchless fashion.
No, we still have to do some of that. The reason being, let's look at one of these examples here. If we look at this, let's change this around so it's either like 0 or 1. It's so the bit that goes in, see how this is like a 0 or a 1 here? Actually BB should just be BB. I think that's right. Let's make sure that that's still correct. I'll explain what I'm trying to get at in a moment. Sorry that I have to go in such a roundabout way. USB CRC examples, make USB CRC examples. Oh no, that's wrong. Why is that wrong? Oh, wrong window. What am I doing wrong here? It's not this. Huh?
So I don't know what specifically you're doing right now because the stream's delayed, but you need that -1, right? Or you need some equivalent, right? You want to turn the value into either 0 or all ones.
Yeah.
Right.
Oh,
and so I don't know what you're doing.
I see. Yeah.
Yeah.
So that was done here. I see what you're saying. So if polyzor is 0, then we don't have to do the zor. Okay, so what we actually want to do is we want to go back to the earlier examples. But it's a little bit weird. It's not just like, is the bit 1 or 0? It's, is the bit...
Oh, no, it's the lowest bit. Okay, at this point, because...
Right.
Okay.
Yeah.
No, I completely missed this. Right. Okay.
Yeah, I don't think I want to mess with that. So I do want to do this, but it's going to be 0 or 1.
Still something. Right. So, gotta be something we can do now that we have that assumption.
So handle 0-bit, what we actually want to do is we want to say like so A0, is that right? A0, yeah, I think so. A0 should be either 0 or 1, but it's like weird because the logic is flipped. Like if it's a 1-bit, it should be 0. If it's a 0-bit, it should be 1. Let's see here. So in a 1-bit case, c.li A0 0, and in the 0-bit case, c.li 1. And then we perform the normal, the XOR, the AND, the add, the AND, the Shirley, and the XOR. Do we still do the Shirley with this? Or the AND? 1 and 1 minus 1 and CRC poly. Yeah, I think we have to do all of that.
So wait, yeah. So what we need for the handle CRC, we can get rid of. We can get rid of that first XOR, and what we can do is we can. So do you remember before how we had like 2 different examples where we sort of changed the logic depending on like whether the thing was inverted or not? So like we had the -1 example, and then we had the negation instead, right? So what we could do is we could sort of do the same thing in that way, and then maybe that saves us the XOR at the start.
What's your proposal?
I still thinking about it, but I think the idea is that we can specialize handle CRC for the 0 and 1 bits and maybe save an instruction in the progress.
I'm just worried because I don't know, because it is a little bit weird. The idea is like you have to take the running CRC 16 XOR, and then it's either 0 or 1. Oh, you know what? You could just look at that first bit, right? Oh, but you can't. It's like if the first bit... Well, I'll let you think about that, and I'm going to move on.
Yeah, sure.
Okay, so let's see if the timing is still lined up. I think that this works. It's really okay if we can't do it, because we still also have like a free NAPA instruction we can do something with. So all of this should work out. Let's see here. As long as we're still lined up. Let's see if we're still lined up. So, like before, this is probably going to be something weird like 33. Oh, 29. What? What? That one's 33. Oh, good grief. 32. I guess I'll just shove a nop.l out here and hope for the best. So that's 32, like we would expect. And then we're going to see between this one and this one, which we just modified. So this should be 31 now, I think, even though I have no idea why. I really don't know why that's 31, but I don't really care that much. Yeah, it's 31. And if we move this over this way, $33, and then I'm hoping the next one is 32, and then we can move on with our lives. Okay, yeah, let's just move on with our lives now. Okay, so what I end up doing is, for the first one, oh, we still need to reset the CRC. Darn. Based on what the command is. So we have to find out the packet type. We get here when we find out the packet type. Let's look at the two what are the two polynomials? A001 and 0x14. Wow, that's annoying. We could do something weird where we like, oh gosh, I don't even know. We have to basically choose between these two polys and decide which poly we're going to use, and in this little window here. This little startup window, and
are we already branching based on the CRC we need?
Nope, nope, we have to do that too. But the current packet type, I believe, is loaded in A2. Yeah. Okay, so when we get here, packet type is loaded in A2. And if packet type is, let's look up USB in a nutshell. They're going to list out the different packet types. Packet types. It's going to be token or data. So which ones are token? Okay, here we go. Tokens. Tokens are any of these. I don't think we have to worry about handshake or special. All we should be receiving from the host is 0001 or 0010. So I think we can and that is 0x xx and it's going to be 01 or 0x xx11. Yeah. Let's see, how does that work? So PID setup, that's going to be this here. So PID setup is going to be 0x or 1101, and let's see if that's it. So I see a 1101. No, that's not right. Oh, it's read backwards because it's little endian. So I see 1011 and then 0100, which I think is correct. Yeah. And so the LSBs are going to be 0 and 0 here. The LSBs are the inverted packet type, though. And so if we branch, we can branch off of bit 2. So I can say, and I, oh, but we want to keep a copy of this somehow. Oh, we already have a copy of this, I believe. Do we? Do we keep a copy of this? Oh, here we go. Oh, yeah. Okay. Well, no, we don't. We'll blow it away if we and it here. Because we store the packet type here, not up above. We should back it up. So, and A0 S2 2, and somehow we're gonna have to, if A0 is 1, then let's see, what was that? Oh no, I'd zoom B out. So 1 0 1 1 0 1 0 0. It's this bit right here. A 0 would be a setup. It's data, full CRC. Otherwise, 0. Setup or partial CRC. Okay. Do we want to do another branch? Because I don't really want to do another branch. Okay, yeah, let's just try a branch and see how this goes. C dot B R, what is it? C dot B, oh, B E Q Z or B N E Z. Yeah, okay, B E Q Z. So if it's 0, then otherwise 0 4. So if it's equal to 0, do setup CRC. And that would be a 0 setup CRC. Otherwise, which one is the CRC register? That's T0 is the polynomial, right? Yes. Oh, we can preload the polynomial up top. I didn't even think about that. Let's do that. Polynomial is already preloaded with A001, so let's just leverage that knowledge. P0 is preloaded with 0xA001 up above. So we only need to do something if it's 1. Oh wait, or if it's 0. So branch NEZ, set of CRC or data CRC. So data CRC. And then right here, what we can do is, oh, I've forgotten. What is it? Let's do A001. And instead of A001, we're actually going to go right out 14 hex. 0x14. And we're going to need to see how long this takes. This could take longer or shorter or something weird like that. I think it's going to be about this though. And actually I think we have to do a c.nop here if I remember, if I'm putting this together right. Let's see how the alignment works, because we do want to make sure data CRC is aligned. And I. Okay. And I A0. Wait, what's wrong? Oh, A0 S2. No, isn't that right? What's wrong with that? And I. Am I doing that wrong? And I.
Wait, oh crap.
Hello.
That's a good question.
Oh no, it's doing the weird audio thing for me again. I can barely hear you. Here, I'm gonna try switching.
No, I was just quiet that time around. It's
maybe it'll clear up soon. I'm sorry, I can barely hear you. Looks like and I should just be and I register 1. Is that not right? And I A0 S2. Is it S2? Or is it A2? Oh, it's A2. There we go. Bingo. Okay, so now what I want to do is I want to make sure it's still all aligned. And then we'll go look at the scope. So here we do our and. Here we do. So here we branch data CRC. Data CRC is aligned. Is end of byte is not aligned. Ooh. Oh no. 224 is aligned. Oh, go.
So I managed to shave the CRC stuff down by a grand total of 1 instruction.
Okay.
The good news is that before we sort of just had an uncompressed instruction in sort of in the middle, which may have been causing alignment issues. I don't know, or might not have been. So the idea is that knowing that A0 is preloaded with the polynomial, we can get rid of one of the instructions, or get rid of one of the non-compressed instructions in the middle of the current CRC loop. Although it's essentially just moving it around because I added it. We do have one non-compressed instruction at the start. I'm trying to work on that for the 0-bit or the 0 case as well now.
Okay, whenever you're done, I'd love to see it. Even though it doesn't look like we'll need the extra time, there's no reason not to keep it, because somebody else may want to try to shove a little bit of work in there as well. Totally random. We really want to make this function be the right sized. So we should probably, now that I know this trick, okay, let's give this a shot. chances of this lining up time-wise are basically 0. But let's find out. So we're going to read from there to, and actually let's just skip one. Let's just see if it all lines up in the end. 68. So no, that did not work. Let's remove that. I don't know if that'll be right. Let's see if that's right. Oh, I love Scotch. Thank you so much. Yes, actually, I love Scotch. I think that would be really cool. I would like to do prepackaged packets. I really like that. That's a good idea. So I love Scotch says that the USB enumeration seems like static, like it's pretty static packet states. This is jumping ahead a little bit, but that we could just store them in the flash and then pipe them out as need be. I think that's a really good idea. I think I'm gonna probably save that for later, but yeah, no, I'd like to go do that. Okay, let's try this. So here, let's skip one. So this is hopefully 66. Dang it. Let's see, is it stable afterward? 34. Oh no. Is this 34? No, what have we done? We've ruined it. Well, let's try to remove this. Remove this, and hopefully that. We might not actually have free time, so removing an instruction would be really cool, a really good insurance policy, Duck. I'm honestly worried now, because last time everything worked out perfectly, it didn't work out.
Wilmore, can you hear me now?
Say it again?
Wilmore's asking whether I'm talking, and the answer is no, I am.
I'm sorry, give me a moment. I have to, in order for me to hear you, I have to reset the audio. Give me a second.
I hear you, Doc.
Yay.
Oh, I can hear you now. Go.
Oh, awesome. So if you could go over those two, those should be special cases for the 0 and 1 bits that have one fewer instruction.
Oh, wait, where did you post this?
In the chat.
Which chat?
The mod book, yeah. The voice chat.
Oh, I see it now.
Those should, I think, work. I think but the assumption is that A0 has preloaded the correct polynomial. Oh, actually, one of those ANDI is wrong. CRT says 0, that should be C that ANDI A4. Oops. So the idea is that it's using A4 as a temporary, A3 is the current running CRT. A0 has the polynomial preloaded. And
Oh wow, yeah, we aren't even using A4 for anything right now.
yeah.
And which one did you say was the polynomial?
A0, because you preloaded it before in A0, right?
No. No.
Oh, okay.
T0.
Oh, T0. Okay, right. I thought you mentioned A0 before. So
No, but conveniently we can use A0 as a temporary. So let's for the CRC code, I'll write out what the things are. Well, you can't hear the Discord stream. Oh no. Okay, say something. Duck.
Hello?
Can you guys hear him now? I mean I see it in the thing. Can you re-explain what you were saying? I'll bring up the oh, I can't bring it up this way. I will bring up I'll write it out. Okay, go. Talk. I have it on screen now.
Hello. Okay. So the idea is that we want to try and reduce the number of instruction used in the sort of CRC function that we have. And the idea is essentially that we want to specialize it for both the 0-bit and 1-bit cases. So in this case, I wrote some code under the assumption that A0 preloaded the polynomial, but I misheard because he actually said, because Charles actually said T0, which makes more sense because that's what what's on the comment at the top. But essentially, the idea is that before we were doing some logic to try and figure out, or to try and like figure out what to XOR and what not to, and or whether to XOR or not, given some logic where the assumption is essentially that our inputs are either the input bit is manipulated in such a way that it's either all 0 bits or all 1 bits, and all this is really doing is trying to reduce, because of the fact that we know that that bit is either 0 or 1, we can reduce the amount of logic that we have to do. And so there were a few tricks that we went over last stream to turn either a 0 or 1 into sort of a bit mask, essentially. So yeah. Now I have to rewrite it in such a way that this actually works.
Yes.
Because I messed that up.
Okay. I will not retime things right now then. I will... Actually, I don't think you need to rewrite it. I think I can adapt your code. So I'm going to comment out my current handle CRC. I'm going to comment out, and I'm going to comment out, and I will write your code in. So for the handle 0-bit, that's this. And what did you say? A3 you said was temporary, right? Or no?
So A3 is the running CRC, A4
Gotcha.
is temporary.
And then, so this is actually going to be A0 now. A0. So A4, A0, A0, A0. And what was A0 to you?
So A0 was, because I misheard you before, I thought you said you loaded the polynomial into A0. So in theory, this was supposed to be an A0. The problem with it being T0 is that can no longer be a compressed instruction, which
right,
is
but we can now change all this around and make A4 our polynomial.
Yeah, that's true. If we can still use A0 as a temporary, we should be fine then.
Oh shoot, hold on. So it would look something like this, correct?
Give the stream 10 seconds to catch up.
I will also paste it into chat so you can look at it on your own screen. Whoa.
Wonderful.
But that is assuming that we make A4. A4 will be the polynomial.
Yes, that looks right.
So
Yeah.
T0.
That would work. And that would be for the one of the cases, I think the 0 case. And then the 1-bit case, we just change the logic around a bit more and it'll be fine. Yeah. So A4, A0, A0, A0. Oh, crap. That maybe?
And this is the other one you said?
Yeah, this should be the 1-bit case, the bit 1 case, because the idea is essentially just that. Is C and I able to access all registers? Maybe, but the problem is that none of the registers that we have, like we have to move into a temporary, right?
Because yeah, A0 is a free register here.
Yeah. Yeah, that's right, but we need the initial instruction here because we don't have a temporary to work with before that, right? So both A3 and A4 are important, right? A3 and A4 we can't change, which means we need to first move into A0 to do all of the important stuff.
Wait, so is this not going to work?
No, it will. It should.
Do you think this will work? Both of your code should work.
Yeah. So the code that you sent and the code that I sent immediately afterwards for the 1-bit case should work. But yeah, no. Wilmore was, I think, asking why we don't have the compressed instruction at the start there, or why we sort of need to do some register trickery to shuffle around.
Oh, stuff. This is weird. What are you doing at the front? I see and I A0 A3 1. Oh, because the operands can't. Okay, yeah, that makes sense. Otherwise, you need to move A3 into A0, then do a compressed and I.
Yeah, exactly. So, I mean, it's functionally the same thing, but without a compressed instruction. So one fewer instructions to avoid.
Right.
And the same size, right?
Yeah.
So, under the assumption that this processor makes sense.
Say it again? Oh, okay.
So, under the assumption that this processor makes sense, and assuming that this is aligned correctly, it should be faster.
Let us give it a shot. I'm going to just run it with your code. We're not checking for validity yet, but we'll do that really soon.
Prepare for disappointment.
Say it again?
Prepare for disappointment.
Oh, yeah. Well, we'll see. It's fine. Well, let's check the speed right now. So the speed should be from here. I'm going to skip the middle mess because it is just such a mess. 58 instructions. Wow, that's fast. And then let's see what the next jump is. 56? 28. So it means we have 4 extra cycles now? What? What?
That's good.
Wow. Let's shove I guess there? Or we'll put compressed no ops at the end or something, I guess. Okay. 4 cycles though? That's incredible. I mean, it would be really cool if we could retime these things off of the syscount internal timer if we had enough time to do that. But I do think that, like, we're getting so many of these speed gains because we can reuse those same 8 compressed instructions. Okay. I Love Scotch says, I make USB automation device to disconnect and reconnect from downstream USB devices. Microsoft pack info on it. I'll send a device to you if you want. It could eliminate manual plug unplug. I don't know if you're going to get it to me before we get far enough along that won't be as big of a deal, and honestly, I haven't need to manually unplug and replug for a while now because it is 99% of the time it does just reset when I reset the processor. But thank you. I don't know. Hit me up on Discord. I Love Scotch. Are you already on the Discord? Okay, well, now that we've retimed, let's see what this is. So the first one was 32. The second one is 36. Okay, well, we'll see what the next one is. 36. What?
Uh-oh.
Let's just delete 2 of the knops and see how it goes. I don't really understand why that's so long. What is going on? Why are these 2 cycles here instead of 1?
That's an interesting question.
Oh, I think I missed it. Yeah, I missed it. And I missed it again. Let's try it again.
Nope isn't coded as ADI 00. Okay, yeah, sure. So it's the same sort of thing. That's weird that it actually takes 2 cycles.
I really don't understand the instruction timing on this thing. I'm hoping we can just figure this out and move on with our lives now. Either that, or if Mossler, if you can figure out what is the instruction timing, that would be amazing. 34. Where is the 34 coming from? 34. What? Why? So if I delete that, if I just delete one of them, what happens? $32. Okay. I literally don't understand that, but I'm just gonna go with it. This should be a nice round 64. It is. Okay, let's see what a 1-bit looks like. $32, which makes absolutely no sense to me. Nope, trumpet suck. This is one of the nice things. I can't remember who it was that suggested we do this, but by showing this clock here alongside our instructions, we no longer have to guess at how long various things take. Instead, we can actually count this, which is the M clock out. CW2. Yeah, thank you so much, CW2. That was a really good suggestion. Oh, do you want them off? Actually, I have to repower both the both things to turn off the WS2816s. What's just wondering, why do you want the WS2816s off? Anyway, let's move on. So when we're done, so I want to include data, length, and CRC. So data is going to be USB buffer. Length is going to be A1 is, what is T2? Oh, it's just literally the USB buffer. Okay. Oh, I see. Yeah, length. Okay, hold on. Okay, so what this actually does is I'm saying the current pointer to which byte that we're currently going to be recording into, minus the start of the buffer, and that's going to be the length. And then the CRC is going to be, is it still A3? Is that our CRC?
Yeah.
Yes. A3 is going to move into A2, which is the CRC. Yeah, let's just go call it and see how this goes. Sure. All this actually does is it just stores the CRC into the PCRC. So let's just give it a shot. I'm not even going to say lay it. We're just going to YOLO it. I don't know really why it takes so long sometimes. Unless something just went wrong. I think something just went wrong. I'll bet you it crashed. Okay. Uh-oh. We will say lay it. Oh yeah, it is super dead.
Uh-oh.
What?
Oh,
look at that.
ABI?
What?
Huh? Sorry, I was just wondering whether it could be like ABI problems.
I think that's possible. Wow, though, it got... I don't know. Well, so it's weird, because it successfully finished this. And I see the mark at the end of like 3 little dit-dit-dit, which the dit-dit-dit means... let me make sure that that's correct. Yeah, dit-dit-dit means SE0. That's like my debug code for that. And it calls it. So why did it freak out?
Are you if you dump the function, like the function you're calling, if you run obj dump on that, are you like clobbering any registers that you're not?
Oh yeah, that's a good point.
preserving?
Let's take a look. A5, we are clobbering A5 to smithereens. Let's see, what are we using A5 for? Oh, you gotta be kidding me. Yeah, we don't save A5 in our call tree. Okay. Fine.
Make sure you don't mess up the stack frame this time.
Yeah, so it'll be, instead of 52, let's just make room for everything and say 64. Or wait, is that like the only one we're missing? A0, no, A5. A5 is being properly restored. Right? Wait, was that the one? That was A5, right? Yeah, A5 is being blown to bits.
I don't think A5 is being restored, unless...
Right here, look at this. Right here, right in the middle. A5 is being restored.
Oh, yeah, wait.
We
actually.
call USB done
There's a
message, pops
difference.
off a bunch, interrupt complete, does
And then you
some weird stuff, and then A5 is restored.
What's in...
Hmm?
Huh. Oh, yeah, that's fair. Okay, maybe.
Oh, hold on, let me see.
20 ESP. No, you're right. Anything else, maybe?
I just turned down the Discord stream, so if it was coming from there, it'll be a little better. Wow, that is really weird. Is there any way else this could be broken? Like, load up immediate 5, store word A1 into the plen, store word A2 into there. I don't see how this could be broken. What? Why no work? Why no work? Maybe it's just unrelated. I'm just gonna go again. Or maybe not. I don't know, man. This is weird. Let's see where it freaks out. That's broken. That's still broken. Oh, they're all broken. Darn it. Okay, let's undo that and see if it works this way. Yes, that's fine. Is something wrong with the call, maybe? Oh.
Call translates to... I think JLR and something else, but
yeah, it changes RA0, right? Or RA.
Oh, that could be.
Load word RA 52 SP.
No.
Sure, why not?
Do the
56.
Do the instruction yourself. Yeah, right. Because I guess
56. 2 store word call. Okay, let's give this a shot. Hey, Hey. All right. So this CRC is wrong, or the CRC check is wrong. Let's see if we can figure out where it went wrong. And so 1, 2, 3, 4, 5, 6, 7, 8. So we'll need 10 bytes worth of data, and then we can try to figure out where it went wrong. Let's print out all 10. 7, buffer 8, buffer 9, %O2x, %O2x. Okay, let's give this a shot. Huh?
Either the polynomial is wrong or my logic is good.
Wow.
Or both.
Or there's so many ways this could be wrong, so.
Accidental register clobber or something like that.
Yeah. Let's see here. So actually the data messages are going to be different each time, so let's just run this. Okay. Over here. What we should be seeing is the last data. Oh, come on. Oh. Sometimes with the USB analyzer, the Sele does not debug the very last USB message, which is the one I need. Well, this one should also be very, very similar. Ooh, that's not good. So C3. So C is 1100. Or is it 0011? I think that's 0011. Yeah, C3. Wait, if it's 0011 and we... Oh, you know what? Our CRC selection code is wrong. So A0, or A2, 2. If it's not 0, then it's high. It's not 0, it's 1. So that's 1. Branch not equal 0, data CRC. No, it is right. It is right. Okay.
No, I messed up the 0-bit CRC.
Okay, well, fix it, and I will try it again.
Give me a moment, yeah.
Also, I'm going to change this up a little bit.
So, the CRT says 0, 2 of the instructions are flipped. The C.NI and the neg should, no, never mind. No, something else is wrong. No, okay, I mean, one way to do this would be, yeah, no, okay, that 0-bit CRC is trickier.
Okay.
In theory, you could do it if you replaced the first. So here, I'll just throw it in chat. I think this should work, but the problem is that you're adding another uncompressed instruction rather than a compressed one. So check your cycles, I guess.
Friday is awake now. Sorry, I missed that. Did you say you did produce new code?
Yeah, in chat there should be a different one. The problem is that this one has 2 uncompressed instructions instead of 1.
Okay.
Which is unfortunate. Yeah, I'm trying to think of another way to get this done.
Well, you could always do something like mv c.mv a0 a3 c. Oh, that stupid neg in the middle. Why?
Yeah, exactly. This is where we're running into obnoxious architectural limitations. God, I gotta think. If I can't, I mean, alternatively, what we could do is, are we using A4 for literally anything? Yeah, we are. We are now.
We are now. Here, let me do a midstream commit.
Okay. Because entirely theoretically, what we could, no, that wouldn't work with the neg. I was thinking we could emulate bitwise not by doing like a compressed XOR. And theoretically, what we could do is we could just have one of these registers just store -1 the entire time, which would be kind of dumb, but we could do.
DIY in the ghetto, you gave me a really evil idea, which I don't want to implement, so please don't do this. But I could, like, for each $1 in the super chat, I give Friday a treat or something. But please don't do that. Maybe each $5, because I don't want him to, like, go crazy. But like, I don't know. That would be. I feel like that would be really evil. Is that a thing that people do, or is that actually as evil as it sounds? Oh no. Friday. Here, I'll turn on some lights so we can start to see Friday. Duck, do you think you're going to have an answer in the next 2 or 3 minutes?
Besides using the negation, no, probably not.
That's so frustrating that you can do, like, 1 minus 1. Like the -1 trick, add I -1 in order to flip it. But you can't, there's no way to just, like, do a neg without, like, an invert flip.
No, wait, hold on. No, but that gives me an idea. Right, I forgot about the fact that we can just subtract again instead, I think. Because that's what we did last time. So hold on a moment, please. I mean, if you, I would give the neg a shot for now, but
Oh, well,
yeah,
that's only,
stay
wait.
tuned.
What you just posted in chat, in the internal chat, is only 1 uncompressed instruction, which is fine.
It's 2.
Oh.
The one that I just posted is 2.
Yeah, okay. Well, let's, I don't know, maybe it'll be fine. Let's see how this goes. Well, it still doesn't work.
And by doesn't work, I'm guessing we mean the CRCs don't match up.
Yeah.
Fantastic. Okay.
Well, actually, hold on. That's even weirder. Oh, something is just super busted. What is going on? Looks like something's getting corrupted. Let me see if our data might just not be lining up anymore, because we could have changed the
timings.
Yeah.
Yeah. Can we also, just for kicks, manually calculate the CRC?
Yes, but I want
And
to hold on here.
Yeah, sure.
We can manually calculate it, but well, I mean, actually, I mean, I don't want to say but. It's just a matter of like we got to get stable data first, and right now the data is not looking very stable.
Right. Yeah.
Which is a deeper problem. Yeah, all of these are correct. These are all 32 bits still. Or 32 time slices, even with your double uncompressed operation. All of these. Ooh, there's a spicy one there. Is it just sometimes 34 cycles? I want to just claw my face off. Sometimes the chip just takes 34 cycles. There's no rhyme or reason.
Is it just any weird like memory access maybe?
I guess. I don't know.
That's weird.
Well, I don't know, man. I love scotch. I'll give Friday a little bit. 1, 2, 3, 4, 5. I'm sure Friday is appreciative. Toucans, no pipelining that we can tell, at least. Well, I don't know why that took extra time then, but the sampling position looks like it should be fine. I don't know what's going on though. It says that the length was 000B, but then I got some trash. Oh. Maybe it really... Okay, well... Let's see here. Let's just try it again. No, it still has trash. 2205. What is 2205 from? Huh. Well, something is wrong with the data. Maybe we should copy out just the first thing and see how it goes. Int 8t did get data. If not did get data, then we do this stuff. And I can say int 32t or uint 8t. Actually, that back.
Another problem in the ZRC test 0.
Oh,
that
good grief.
neg A0 A3. That neg A0 A3 should be neg A0 A0.
Oh, that makes sense.
Yeah, because yeah, it doesn't really make yeah exactly.
Well, I'll fix that right now. Okay, that's fixed. Okay, so that's like mega wrong. 3 bytes, 0805? Well, it's stable. We just got it again, whatever it is. Let's try to figure out what's going on there. I have no idea how this thing could get... I mean, 1, 2, 3... Is this right? So it's 8, 9, 10... 11. No, I don't know how this works here. Oh, I did just notice we probably need to make sure that we write out the this thing when we're done. Let's see if that gets us more reasonable data. I'm going with no, that is not more reasonable data. Crud. Is somehow this getting called spuriously?
Other problem. I don't think we're ever properly initializing A3. Like, A3 should be initialized to the who's even what's it, the right initial value?
What do you mean the right
CRC
initial value?
Like
Oh.
CRC 16 start.
Oh, that's a... Oh, LI A30. Okay. We'll do that somewhere later, I guess. Or where's some NOPs? Oh yeah, we can do that right here. That's fine.
Yeah.
Wait, did I do that wrong? Did I do that right? Let's look at the listing. $1D0, that's good. Let's check. Next one is data CRC 14. End of byte 0. Handle 1 bit 0. Yeah, it looks like all this lines up. I don't get this. 1405. What? Where is this coming from? Actually, this is even more concerning because what I just changed was I said load immediate A2 AA A2 into 0T T2, but like AA doesn't appear anywhere in here. What? This is just garbage data. What is going on? How? Wait, did I? Well, like what? How could this be messed up? T2. What is T2? T2 is USB buffer. LA T2 USB buffer. We write A2 into T2's address, then we add I T2 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 A0. So we subtract them. And A0 is USB buffer. That's how we get the number 4, which is right because it's 4 bytes, I guess. Then we call RVO3 USB handle packet. If didn't get data, then did get data. Guardian presence. All I need is RSSI program for millions. I don't understand your comment there. Wow, what is going on here? Where is this coming from? What about it? ESP8266 can do RSSI. That works quite well.
The fact that CRC is also very odd is setting off alarm bells. In my
This
head.
is triggering, I believe, is a setup packet CRC. So 9 is not an unexpected result. What is unexpected is that the data is totally trashed. Like this right here.
Wait, this is a CRC 5 then? Wait, what? Why is 9 an unexpected result? But yeah, that's also a...
No, 9 is a fine result. Well, it should be something else. I don't know what it should be, but like the data itself is getting...
Yeah.
Something is hosed. Because I'm saying load immediate A2 AA, it should store that in what T2 is pointing to, and then increment T2 T2 Let's make sure that that's not something silly. Let's see what this says. Yeah, it says add I T2 T2 the decompiler. No, this is not noise. This is just like wrong. 863. This is, I'm not sure what's going on here. Let's make sure that this isn't crazy. Load immediate A2 170, store byte A2 T2, add I T2 T2 Where is T2 used? Let's make sure we're not doing something stupid here. Nope, that looks good. You know what? Let's actually run this in the debugger. I want to make sure that T2 contains the right value. Clean all GDB server. GDB dash multi-arch rv blah 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 dot elf target remote local host 2000 b rv03 usb.s line 312 c. Oh, yeah, I guess we do have to, like, reseed it. Okay. Layout. Assemb. Layout next. Layout next. Ah, there we go. Let's see here. Oh, sure, whatever. Let's see. T2. 2050. Is that the right address? Let's look at the map. Uh-oh. 4C. Oh, yeah, here it is. 4C. USB buffer. Yeah, it's writing into USB buffer. It's on the 4th byte. What is T2? Or, sorry, A2. Info registers. A2 is 170. Ooh. USB, what is it? Buffer. Okay, this is even weirder. In here, if I look at USB buffer, it's B4, which I think is actually the setup code 000001, which I think that should be all correct. Blah 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 blah. Let's see. Not perfectly correct. So that's weird. The whole thing looks backwards again. Oh, whatever. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. That's the first 0. Then 1, 2, 3, 4, 5, 6, 7, 8. So that's 4. I'm not really sure where the 1 is coming from there. Oh yeah, that's exactly right. This buffer here contains exactly the right data. So USB buffer is completely correct. A0, let's see where A0 points. Wait, how do I... A0 is pointing directly to the right place. Okay, fine. Print did get data.
You're missing a... Wait, hold on. Go back to your main code.
What do you mean my main code?
The main.c, where you're actually printing it out in a loop.
Okay.
Hold on, am I missing something, or are you doing, you're casting to a uint t instead of a uint t star there?
Oh, wow. Good call. Let us take
Because that would cause
exactly this problem.
Minor issues. Yeah.
Oh, I don't want bag. I want this monitor. Okay, that's a little bit better. Yeah, and the AA is getting through now. B4 is actually, I think like what's going on is that's actually backwards. I think if I remember, let's see, so from last time, one of the issues was I was reading the words in backwards instead of forwards. Let's see if I'm doing that here. Packet type loop, a blah blah blah, right header, or okay, so the actual issue, oh here it is. Write the bytes in reverse order because we can. Oh great, that was a Charlesism. So what we really want to do is we really want to point out warning, A2 is bitwise backwards here. So when we say A2 A2 2, it's the other way around. So like branch EQZ, because before where A0 is going to be 0 is our setup packet. Oh no, it's still not equal to 0. Okay, that's fine. Well, that's weird, but 0xb4 for instance is a setup packet. So 0, A0, 0, branch not equal to 0, data CRC, but it is 0, so we load in the polynomial for that. Okay, well that's fine. Let's see what is the answer. It should be 0x16. Well, that's pretty cool. Okay. That's actually really cool. Let's do a little bit of tweaking here. Actually, toucans, let's see. Maybe it did warn me and I just ignored the warnings, because I do that a lot. Oh yeah, look at that right here. Warning. Cast from pointer to integer of different size. Yeah, I was casting from a pointer to a uint8t. And because this is a bit of a weird architecture and they encourage running from flash at 0 instead of in the flash zone for some reason, you can just read from like null. So...
Oops.
Okay, so that's better. Actually, a lot of this is better. Your code might be correct. One of the things I want to do, though, is I want to flip the thing around. So I want it so if the CRC is correct, the check will be 0. That's what I want to do. So let's just see how we can do that. I think if we do 14... Oh, actually, let's record the time. So this was 1:51:16 was... We have a valid CRC on a setup packet. Although I do question if the CRC is valid. I'm really confused by the 01 or 100 in the end, but maybe I'm just off by 1, or maybe the CRC is actually being like, yo, like it just didn't detect it because there were 2 errors. Anyway, let us next Where's the... Here we go. Which polynomial do we use to start with to make the answer 0? So if one polynomial seek to find a 0 start polynomial. Int start poly equals 0. Or start poly, yeah. And sp equals 0. Sp is less than... What is the size of a CRC5? That's less than 32. SP++. And we're going to go run the polynomial code where our first value is SP, and we want the situation where if CRC5 is 0, printf found good start poly 0.8x or 0.2x, and that's going to be SP. 1e is our start poly. E, and our good poly is going to be 0, 0. Oh, that's wonderful. So now what I've done is I've made it so that if we can at the end of our of getting all the USB decoded, it will be 0, 0 if the CRC is good. And so now I'm going to do exactly the same thing for a CRC 16. That's because if we can front load this work, that's really cool. 65536. We're going to use the CRC 16 poly stuff here. And poly seek. And this is going to be CRC. If CRC 16 is 0, then printf found seeking poly 0 for x sp, and let's see how this works. Oh, we have to say yes, we want to execute. Oh no, we are. Well, that's odd. Should at least find one. Alright. SP CRC 16. Oh, we have to go through all 65,000. Okay, so it's going through them. Let's see here. F0EB, it says, is a good start poly.
Wait, a good start poly is when the CRC itself is 0?
A good start poly will lead us to be 0 at the end.
Huh.
Bingo! Look at that. All zeros. That's great. So what my goal is I want to make it so that I initialize the CRC to F0EB, and if I do that, then when we're done, it's going to be 0 if it's correct.
For the setup packet, you mean?
Well, for the setup packet, it's going to be 1E is what we're going to set up to.
Okay, so same idea, I guess, right?
Yes. So that'll be LIA. What is the poly for this? You were just working. It's A3, right? Is the poly? No, not poly. A3 is the running CRC.
A3 is the running CRC. A4 is the poly.
1E.
I think we said A4 for the poly.
A3.
Yes. Yes, we did.
Then the running CRC for this is going to start at 0x4FEB, so that if the CRC is correct, it will be 0. Okay, let's give this a shot and see if this works. It says 0, 0, 0, 0, 0, 0, so that looks like that might have worked. Now what I want to do is I want to do, if this is, if this is greater than 0, this minus minus. If it's equal to 0, then we do that. Otherwise, it'll be -1, which means done. The idea is, like, I want to get the second packet in the list. So let's give this a shot. Wonderful. Wow. Actually, I think that just worked, because it says that our data is C long, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, and we're corrupting it with AA, but that's fine. And the polynomial is 0, so I think that all worked out. Yeah, I'm gonna check this in. So our CRCs are good now, I think. Update CRCs so that they are 0 if correct. And oh man, we could also just do the CRC in the assembly. Yeah, we should do that. So that way we don't have to pass it into the C function. Update the CRCs so that if they're 0, it's correct. And we are getting good CRCs on both data and setup frames. Oh my gosh. Thank you so much, Duck. That has been a wonderful little exercise there. I guess next, let's check the CRC down here and make sure that it's like good before jumping into the C function, because there's no reason not to. We also don't want to corrupt the last byte. Oh, we also want to say we don't want to write out another byte if, okay,
Toucans wants to know what to do, or what will happen if the CRC isn't correct.
If the CRC is corrupt, you just don't listen to it. You just ignore that it ever happened. One of the nice things is that the host will just automatically retransmit. Oh, and if you're wondering, how does the client know if the host is retransmitting, or if it's like actual data, like if the ACK gets set? What USB does is it sends data 0, then it sends the data, then it says data 1, and it sends the data. If it's retransmitting, it'll repeat. It'll say data 1, and then you know you can just throw that out. Message, we want, uh-oh.
Back in roughly 30 seconds.
Oh no, what's going on? I just lost my stream. Is it going? I can't tell.
I think we're okay. No, it seems to be going.
Okay, that was weird. I guess I lost internet briefly. I'm gonna pull up CN ping then. I think we actually don't need to handle this here, but we do need to check to make sure the CRC is okay. C dot B NEZ, and the CRC is in A3, and we'll just jump down here. If bad CRC, skip ahead. Good CRC. Then we don't even need to do this. Neat. Okay, that's actually really nice. And then in CLAN we don't have the CRC anymore. Make sure the code still works. It looks like the code still works. We're still getting messages. It says their length is B, so let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B. That's it. Yeah, A, B. Good. That looks great. This is actually working. We are sending messages from the PC, and we're getting them on device. And we're only 2 hours into this live stream. We have a shot at sending something back today. I'm gonna go for it. We're gonna go for the gold. Let me mark this down. 20400. Having messages valid and CRC checked. Okay, let's just commit this. Do CRC checking in assem. Wow, that was nice. All right. So now we're gonna want to be, I don't know, maybe we'll want to do something super clever. I don't know. Let's see. What is next up on this? So if we have a token like setup, what does the setup actually contain? Setup contains address 0, endpoint 0. There's a special thing. Address 0 is not valid as any device which is not yet assigned an address must respond to packets sent to address 0. Okay. Okay, so if it's... I think I want to actually expose this right now. Well, no. Let's do switch buffer 0 case. Which one was the first one? It's like B4, I think. Case 0 is B4. Setup packet. If. And what are we looking for? We are looking for the case where address is 0 and endpoint is also 0. So, and let's actually just double check that. I want to make sure that this is going correct. So we want to do did get data 0. Let's check this out. Yeah, David, this has been pretty cool. This is all worked out. So B4 0010. Why is this 0010? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Yeah, that's right. What is the set of packet sizes? It's here we go. Sync, PID, a dir. How big is a dir? 7 bits. Enp. I think enp is 8 bits, if I remember right. Oh no, 4 bits. So 7 plus 4. But really all we care about is the first one. So buffer of 1 and 0x least significant 7f in setup mode is true. Uint t in setup mode. I guess the other one that we want to do is we want to make sure this is the data actually required for USB. Okay. Else in setup mode is false. Break. Yeah, it looks like, I mean, at least, unless there's something weird happening that's, like, tricky, I think this is working. Side note, I don't know where Friday went. Huh.
Cat cam is sparse.
Say that again, Duck?
Cat cam is sparse.
Cat cam, yeah. Oh, yeah, Well, you could always, summon him. Wink, wink. Kidding. Please, yeah, it's okay if you don't. Default, we're not going to do anything. But what we do want to handle is... what is it, C3? Data 0. C... oh gosh, what is data 1? C3. What's 7? No. Oh, there he is. He was hiding behind the air conditioner. 4B. Data 1. Okay, so let's see here. What is the very first message? Data 0, request type 80, get descriptor. Ooh, this, I didn't realize that. I thought there was a set address that has to happen first. Hi, Jack. Okay, well, oh, yeah, thanks. Well, thanks for coming, and I guess that you're not going to stick around. Yeah, this writing a USB stack from scratch is definitely a tricky thing to do. But it is something that is absolutely tractable. I remember in college when I first read about VUSB, and I was like, wow, that's amazing. I would never be that good of a programmer. And then I just kept working at it, and eventually I did get a chance to, like, learn how to write it myself, kind of thing. Although VOSB is really tricky. I don't know if I could write that myself, but I can get pretty close. Let's see here. If in setup mode, we probably want to do most of this logic in assembly as well. Like, looking at this, it's probably going to be better for us to write this in assembly. So if we're in setup mode, or if data receptive, thank you, Jack, for the vote there. Do which in 8 hours, Spirit? Write the whole stack in 8 hours? Because that was definitely optimistic. This is much more difficult than I remember it being, even though I've already written this once in with ESP-USB. Actually, honestly, I'm going to just take a real quick break here, but I want to vote from everyone. Should I, at this point, look up a reference? My reference, which is ESP-USB, which I did for the SPD266, and just kind of copy some code, or do we want to figure this out from scratch? Let me know. I'll be back in a minute. Oh no, what was the super chat? Cat? Okay, $5? Okay. I will give Friday a few little snacks. Alright. Hey Friday. For the camera. Here. Okay. Copy all the code. Copy it, write it once, run it many, right? Please copy. Alright, I'll take a look at my reference. Just so, I'll use it as a reference to tell me, like, which way to go. Because it's been so long, I don't really actually remember myself. So let's look under user. Let's see where we end. Like, in ESP-USB, I actually don't know where it ends and where it, like, other parts begin. Okay. So it looks like here That's impossible to read. Yeah, it looks like... Also, I just noticed in. What is in? Oh, in token and out token. I actually rather like that. Doing this logic inside of assembly is a lot cleaner, it feels like. Well, I don't know. We'll see how this goes. Okay, so then what I want to do is look at the code for PID handle setup. Oh, there we go. Oh, wow. This is actually not that bad. That's also kind of funny. I never even thought about that. I avoid a function call because I know where it's going to return to. I think I might actually want to do that because that's kind of fun. Maybe not right now, though. Maybe not for the stream. So we say if address is not equal to 0 or my address. How is my address set? Ah, it's a special message that says set address. So there is get descriptor. What is this? B request is get descriptor. B request is get descriptor. Okay, so we're probably gonna have to get descriptor. I wonder if we can just lift the code directly out of ESP USB. Is that cheating too much? I think that there's not a lot of code here. That's actually really not a lot of code. Maybe we'll do that. And I'll even do the same trick that I do there. Okay, so we'll go get the code ready to be run that way, and we'll see how this goes. So yeah, let's do that. Okay, everybody's saying just go for it. Okay, yeah, we'll do that. So we've restored X0. We know we have a good CRC. Now we have to decide what we're doing based on the packet type. And so what we can do is we'll have to see if it's a token or not. So what we can do there is, well, actually what we really want to do is load word A0. Oh yeah, load word A1, because now we don't care. We can throw away all of our variables again. 0 A0. So A1 contains the reversed packet type. And then what we're going to do is look at what is that bit that we want to look at. A2, A1, 2, and we're going to say is data packet. I guess is it a data packet? Is that what they're called? Yeah, they're data packets. Definitely data packets. Otherwise, else is a setup packet. Actually, this is convenient because the setup packets do need to go like really fast. Okay. USB message in. So we know it's going to be a set of packet of some kind. And the ones we care about are in, out, and setup. We're not going to handle softs because those are actually keep alives, I found out. And so what we can do is we can say sub I A2 A1, and we give it the code that we want to check against. And so 0xb4, and that's going to be a setup packet. And we're going to say c dot b nez, or branch qz a2, and we're going to jump to, and what was the name of that function in ESP USB? It's going to jump to USB PID handle setup. Okay. Sub I, A2, A1. Actually, this is really tempting, because what we can actually do is like keep subbing it, or like adding it and moving it around to get what we want. That would be, that's too much fun. Let's do it. C.sub I, and also, I guess like the other thing is like this code is kind of trivial, but what I'm doing this neat little thing right here. So A1, so if there's 0, that means that the incoming value was B4. But next we want to check for c dot add I A1, and what we want to do is add back in B4 to get the original value back, and minus. And what's the new value? The new value that we'll be looking for is an out token. And that would be why is this B4? Is it? Oh, that's right, because it is backwards. It's 1101. Okay, so this is read 8. So 0x8 7, I think. Yes. 8.7 will be a out token. And who knows, maybe we'll mess that up. C.beqz A1, and handle in, handle out. Okay, so we'll call this function boom. And we don't want to use A1 now that I'm thinking about it, because that's going to just be 0 all the time for this. So what we really want to do is, it says, well, this token, oh, interesting. What do we do for setup? This token is, okay, so that's interesting. What this actually does is, let's do this a little bit differently. A5 will be the USB buffer. A5. We're going to load word A0, and A0 and 1, and C dot MB A4 A0. So we can work with A4 here. And A0 will contain the token, the first 4 bytes. That's what ESP USB wants. That's what we'll do. And the second one is an internal state struct, which we don't really do that. I guess we have to. Okay. Struct RV03 USB internal. What is it called again? We're gonna name it a little bit different. USB internal. And what is in that structure? A lot of stuff. Ugh. Ugh. It's too big. What is last token used for? It's just not used. Cool, that's nice. Oh my gosh, that's so much stuff. Well, let's see how this goes. I think we do need my address. We need to know if it's a setup. Okay. How many bytes do we need? 16, sure. uint 8t. What do we call this buffer? USB buffer. Boom. We're gonna keep packet size uint 8t. Packet size. I don't want to do that. I want to just pass that in. Yeah, we'll just pass that in. uint 8t. Setup. Request. uint 8t. My address. That's all I think we need right now. RV blah, blah, internal data. Okay, so LA2 blah. So that would be a 0, a 4, a 3, a 3, a 2, a 1. This is actually gonna be a 1. Okay, so we aren't gonna have USB buffer anymore. We're gonna have this right here. USB buffer. Number of bits. That all looks good. Okay. Nobody's talked in a while. Is everything okay?
I'm alive.
I guess I'm just like in
I was actually
go.
Oh yeah, I was actually wondering, is the compressed instruction in between the middle of the two normal instructions? Is that
Where?
good or bad? I actually don't know.
Where?
You had a c.mv, like where you were just working. You had a c.mv in between, I think, an ANDI and the store.
It's fine. It'll deal with it. It's
all
just
right.
slow.
Yeah, that's fair. No, I'm just wondering whether like how does that? What does the compiler just pad it with hops? Like
What? I don't understand the question. Oh no, there's no NOPs. When you do RV32C, you're allowed to align your 32-bit instructions to 16-bit addresses. It's just slow.
oh, okay. I was wondering because
Not supposed to be slow.
It's supposed to
Wow.
be faster, but it doesn't work out that way on this architecture, apparently.
Running them isn't supposed to be slower, but branching to them, no guarantees.
Well, running them, from what I can tell, is sometimes slow. But I haven't been able to find a rhyme or reason about it.
That entire fiasco
Hassler.
before where it just
Wait,
Slow
what?
because it has to do two fetches. We have no idea, if I recall correctly. Like, the whole thing about compressed instructions being ridiculously more efficient than uncompressed ones.
Ridiculously?
Or just alignment. Well, I think like maybe a stream or two ago, yeah, we were having this thing where we just moved a few things to being compressed instructions, and all of the alignment and stuff was the same. But it was in a hot loop, and it was a lot faster than we expected to be. If I recall
Yeah,
correctly.
that was voodoo.
I don't understand. One day, we need to figure out exactly what the rules are for this architecture.
Mossler seems like they're pretty interested in figuring that out, so I'm kind of excited.
Yeah,
Yeah.
I really want to know like what exactly the real logic is. You know, what's snake oil and what isn't.
I know the core
Motorola.
isn't very pipeline.
What? Go.
Go. I know the core isn't very pipeline, but I'm still curious if there's any use after write dependencies.
Oh, I don't know for sure either about that. That's still something else to check out.
Hey, Duck, you said Motorola? What?
I did not say Motorola.
Oh, sorry. No, I said Motorola because GitHub thought that this code is Motorola 68K assembly, which is patently wrong.
No. No.
Wrong microarchitecture.
If it were, it would allow bit field addresses up to 32 bits signed, which is crazy sauce.
The funkiest architecture I've even looked at so far, or like even heard of, I think was like Super H or something like this. It's really weird. Like 16-bit instructions, but 32-bit addressing, and there was this whole. It was weird.
You mean like the Dreamcast?
I have no idea.
Yeah, that used a Super H processor.
Ah, cool. Yeah, I need
I
to
have one in the basement if we need to dig that out.
I don't think we will, but it's
Fine. It runs Linux though.
Oh, that's cool.
Poor Sega. I love Nyet.
It was a different architecture. I think it was PowerPC that can apparently just switch endianness at will. That's funny. It might be PowerPC. I actually don't know, but yeah.
They did have a lot of endianness stuff because of their history with Big Endian through the IBM systems before them.
We also want to handle an ACK handshake. Oh boy. What does an ACK handshake look like? Handshake packets. Oh, it's just literally only the thing. Okay, up here we have to special handle ACKs, I guess. I am really bad at writing this out. Maybe I should stop trying to use hex and just write it out in binary.
That's what you did in the other one.
Yeah. Yeah. One oh one one. Out is okay. Night in the Ghetto, DIY in the Ghetto.
Always listen to the better half.
Say what?
Always listen to the better half.
Aww. Whisper sweet USB nothings in her ear.
Oh, that gets a hard knack from mine.
Oh.
Okay, Charles, ASMR mode.
What?
That's playing with fire. I'm trying to figure out more about the actual chip that they're using for the CH32V003, and there's nothing. Very.
Oh yeah, the Kingquit Core 2 or V2 is just not documented.
Yeah, no, it. When you Google it, the thing that comes up is the CH32. Yeah, like, very helpful, guys. File type .pdf.
Sort of feels like someone's thesis project.
I think it might be based off of all of the engagement that Patrick has been engaging in the community with.
Yeah.
Like it like when I talked to him on the phone, it was clear that it was like it's his baby. Like he cares. So.
Oh, his specifically?
Him, I think it's him. I didn't ask him if he wrote it, but like it's really clear like he knows that core. So he may have been like the project lead or something, I'm guessing. He just really which is surprising that he does so much public facing stuff, but like he knows that core. So
yeah, he always seemed like the business face. I assumed it was like a buddy of his from college or something.
Maybe, but he knows what's going on there, so
that's cool.
We need to detect an ACK packet. 0010. Or it's 0100. 0B 1011. Okay. C.branch EQZ A4. And what is this? We are branching to ACK. We have to find the ACK. Oh no, is ACK cursed? Oh no, here it is. USB handle ACK. Alright, so for setup, it's USB PID handle setup. Okay, so for that, it's USB handle out. Okay, for
Oh crap! I found a PDF file.
Which
Hold
one?
on.
There is a PDF on the core.
Yeah. Hold on. This says
It doesn't
has
tell you
branch
much.
prediction. Oh, good.
All right, and then we exit out. I think that's all we have to do here. We're still going to need to write the code to actually send data, but that's pretty easy. Wow, this last couple minutes has gone quite quickly. I guess we don't really need this function anymore.
Yeah, this PDF file mentions the word branch prediction twice. That's kind of I don't know, mildly terrifying in terms of
Less than helpful.
yeah, not only less than helpful, but also, oh crap, there might actually be a branch predictor.
That would be awful. All right, let's delete this code here.
There are crazy folk who've looked at old x86 chips in crazy levels of detail to see how their branch predictors and stuff work. I mean, we could invoke their name if we need to.
I find it hard to believe that they would care about a random 2-bit Chinese 10-cent microcontroller that has no history. But, like, one of the goals here is to make it so people care about this. So, if we do interesting things, they will come. The smart people. They, like, wander out of the spaceship.
Build us and they will come.
16-bit compression instruction for self-extending byte and half-word operations. What?
All of those words sound terrifying.
That's the load and store instructions that do the sign extension. We looked at that last stream. And the other ones they mentioned in that are the low power mode ones to put it to sleep and to wake it back up. Or at least that's what Google told me.
Yeah,
Yeah, Alex Stardov, you're right. They have the 2 series of cores, which is only the one, and there's the 4 series of like A, B, C, and D. And I don't have a cheat sheet to figure out what the difference is on all the 4 cores, but there seem to be quite a bit of variant.
I remember one of them, like, I know one of the things is one of the cores has hardware to make interrupts like mega fast, but it's not ours.
Yeah. They have a shadow register set, or a couple of them. Which, of course, is just begging the question for the next IRQ, unless you do tail optimizations, which they do.
Speaking of tail optimizations, that's kind of what this is, where we're just going to jump directly out of the function and back into the fun place.
You know where the function's going to return to. It's just an inline, right?
We can't inline to assembly, unfortunately.
yeah,
Well,
you can just call though.
Ooh, also this is kind of gross. We have to tell it which ACK we're doing is the third parameter of the data. Ugh, how are we doing that?
Oh, hey, bit loony.
Oh, hey.
Hello.
C.load immediate A2. So this is going to be 0. And this one is going to be 1. Wow, that actually wasn't that hard. Okay. So now we want to make sure that we do this at the end of all of these so that they don't return out. They just go here. Wow, that's kind of fun. Okay, so next thing we're going to have to do is implement USB send data. What in the world is that? What does 2 or 0 mean? Yeah, the last couple minutes kind of went fast. I don't know. It seems like it's going pretty cool.
More hacky than expected? Is that possible?
What in the world is the prototype of this function? Oh, come on. The one time I actually want this find functionality on this. Okay. Oh. Okay. I see what I did there.
Soon time?
Thank you. Hi, Grilled Co. And yeah, BitLooney, this has been a lot of fun. We will write this function later, though. Data length and poly. So BitLooney says, I feel sneaky having a garbage full of cool vehicles and just waiting for you to finish building the engine. Oh, I feel kind of honored. I don't know. It might work. I still don't know. This might have some issues, but looks like Friday's up and about. Let's see. How did I write this function here?
It needs as much board space for all the USB hubs as you need for the actual chips.
Wow, this send function is complicated. I'm gonna rewrite all of that. Yeah, about that.
Sam finally timed out.
I don't know what XW is, by the way, Michael. I don't know what the XW extension is. I would love it if somebody were to like actually make a cheat sheet of all of the assembly commands that this chip supports.
I'm actually looking at that right now because I had the same exact trouble. They refer to the XW extension and then they say they extended the XW extension. And neither of these things are ever mentioned anywhere else from what I can tell. So your best bet might literally be to like grab their GCC fork and see what instructions they emit that aren't standard.
Not looking.
Those were the
That's somebody else's problem.
sign extension ones for byte, word, and unsigned.
Yeah. Those are the ones that we see here for like stack-based addressing.
Yep.
Is there literally like, is there a data sheet for this somewhere? Because I sure as hell can't find one.
I found like one hit when I Googled for it the last couple times.
I'm trying to remember, what was the difference between caller and callee again?
In terms of like saved registers?
Yeah.
So a caller saved register. I mean, well, generally what you're talking about is like volatile versus non-volatile, right? So all of the saved registers are ones that anytime you like call anytime you call a function, you can expect those registers to be the same after the call, right? So anything else that isn't marked as like saved register, has to be assumed to be garbage.
Wait.
So like A0. Sorry.
Okay,
Yeah.
so anything where it says -r, I can totally trash and be totally fine, right?
Good question. Yes.
Okay, then I'm going to back
You
up
can-
S0 and S1. And then I'm going to go to town. Okay, so once we're in here, A0 is our data, A1 is our length, A2 is if we are emitting a poly. Is it C.LB? I always forget this. I guess we don't show it yet. Yeah, I guess it is C.LB. And we're going to use S0. And we're going to read from data. And we're going to say add I. Oh, data is not that. Data is A0. It will be actually our end. C dot add A1, A0. Add I A0. 1. Sub. I really wish that there was a compressed instruction for comparing these two. C dot. actually, we could just do this. Okay. So here we're gonna do. Oh yeah, I'm moving them into T0 and T1. Yeah, and sure, it's a more dangerous place, but I can't use T0 and T1 with compressed instructions, and I really want to do them with compressed instructions. C.B NEZ branch not equal to 0, or C.BEZ BEQZ. Done sending data. Okay. Our inner loop. Ooh.
See you, David.
Wish I could have been more help, but good luck, guys.
No.
Oh, thanks. Bye.
Thank you.
Things have been going well.
Yeah.
This, man, I'm.
Well.
If we don't finish tonight, I'm gonna be really sad. Like.
Same.
I unfortunately have to tear something down outside in a few minutes. Actually, I have to do it right. I'll do it during my next break, and then I'll get back to this. I guess probably next break will be in, I don't know, whenever we finish writing the idea of how this function should work, and then we'll see how it goes. I just realized this is not going to work. Whatever, we'll figure it out later. C.li S1, and that's going to be, our first state is going to be 0. And anytime we send a 0 bit, it means that we have to flip the state. Anytime we send the 1 bit, we don't flip the state. Okay, so really some of the other things we're going to have to do here is load in the GPIO register. a minute. Oh. So we're gonna have to go switch the line to be output, and then we're gonna have to bit bang it out. That's annoying that there's no bit banding on the registers. So we're gonna have to actually do like real work to figure that out.
So we have to do all of the stuff we just did in reverse?
Yes, but it is much, 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 much easier.
That's
I
good.
think. I hope. Well, I guess no time like the present to figure out how we're gonna do that. Man, that's really sad that the I'm down to 26 viewers right now, but I don't know. I've really been surprised by how many viewers watch this after I'm done.
Well, it's approximately 1 a.m. on the East Coast right now, and I mean,
Yeah.
that could be one of the reasons, just time. And so, I don't know, depending on where your viewership is. Like, the people in Europe are just now starting to wake up, and everybody on the East Coast is asleep, and also it's Saturday. It's Saturday evening. So, combination of things, but yeah.
So I'm just going to convert D plus D minus into inputs. Wow, this is cursed. How am I gonna do this? C or load immediate. Oh gosh. Oh, I hate stuff like this. This is gnarly. And so much room for error. Times 2. Oh. BP.
Data. Is there any type of like race that can happen here where host is
Yes.
sending data?
Yes.
Ah,
You just got to deal with it, and or just hope for the best.
oh, good.
Actually, this is even more annoying because we have to set some bits and clear others. The outputs.
Sounds like fun.
We're gonna have to reset both of them. Hey, Duck.
Wasn't me.
Oh, wow, Wilmore, you're back. Just in time for me to... I really have to take a break in a moment to put together a thing I have outside.
Alright.
I have like 1 more minute. I just really wanted to get the kind of framework of this down, and then I can think about it. Actually, I can commit it, and then at least 1 or 2 of you guys can... Oh, consider letting Spirit in. That's a good idea. Why can't I invite Spirit? Every time I have to remember that the button to do that is not where I think it is. Okay, I've allowed so Spirit can come in now.
Yay.
So it'll turn into universal this mode.
And he's gone. Oh. Alright.
I'm just randomly picking 2 megahertz. I don't really care. Any of the modes are fine. The difference is how quickly the output FET's gate gets changed. So the actual drive current is the same. So the drive strength is identical, but the not drive strength. Yeah, the drive strength is identical, but the speed in which it gets to that drive strength is slower. Nope, we're not using pull-ups for the USB. I mean, we are, but we have to use an external one, I think. It'd be a lot of fun to try it without that external pull-up and see what happens if we just use the internal pull-ups. But that's not for right now. That's for us playing with this later. Okay, so inside here, we want to see if the LSB of and I A3 S0 1. Yeah, LSB first. And XOR A3 S1. I mean, I understand, Alex, that the internal ones are literally 2.5 orders of magnitude too much resistance. You never know with these things. Sometimes you get lucky. I always forget this. Yeah, so XOR is only 1 if the values are different, right? I always struggle with that. I've been doing this for like forever. But 1 XOR 1 is 0. Yeah, okay.
Yeah, 1 XOR 1.
So... Yep. So we send a 1 bit. We really don't want to do anything. So actually be... we send the 0 bit, we want to twiddle the 2 lines. A3, and it's going to be... Well, we're going to blow all of our temporary registers here. All of our fast registers.
Oh no. Well.
So our default line state is going to be 1 arrow D minus. not doing CFGLR. We want to do OutDR. Oh no. That's the stupid. Is that. Does anybody know OutDR? Okay, I've got to go for a moment, but can anybody in chat tell me, is OutDR for outputting things which are already outputs? Or is OutDR for, like, changing a thing from input to output? Because I can never remember, because I do know how to do it with BSHR, but I don't remember how to do it with OutDR. Yeah, if you can, just, like, say that in chat. I'll be back in a couple. I have to go move a thing. Be back in about 8 minutes. All right. I
back?
am back. Come on down. Come on, Friday. Come on. Come on. You gotta come here for the camera. Good boy. You're a good boy. Okay, so what was the answer, guys? Is the, what does that register do? What does outdr do? Should I go look at the direct I/O example myself? I could also, I guess, do BSHR stuff because I know how to use that, but it's a little grosser. Okay, I'll go look at the example myself. Actually, no, I just realized I basically, sorry, I don't know why I didn't think of this. I have to use BSHR because, as you point out, the atomicness of it. I can't not use it. Ugh, that's annoying. I don't want to do that. Whatever.
Knock, knock. Race condition. Who's there?
Right, but if you use BSHR, it won't do a race condition.
Yeah.
Man, that's annoying. Oh, I already have it.
What makes BSHR... Oh.
Say what?
What makes BSHR more obnoxious to work with in this case?
BSHR says, I want to clear these bits, and I want to set these bits, and I want to do all of that atomically and not touch any of the other bits.
Yeah, so that's fine in your case. I'm just wondering, like, why you said this was uglier.
Because I have to use larger values, whereas with the other mode, I can use much smaller values.
Ah. Right.
So, like, it gets a little bit weird. So if I want to say, I want to turn on USB DM and I want to turn off USB DP, I have to do this, which is really gross, but whatever. What did I just change?
Does LI let you load in like?
Yes, it does, but it becomes 2 full 32-bit instructions.
Does it do like? I'm guessing it automatically turns into like what, LUI and LI?
Yeah.
Or whatever.
Yeah.
Yeah.
Toucan says if it works like the STM32 analog, if you set both clear and set bits, the set takes priority. Oh, okay. Yeah, but that doesn't really matter to us. Oh, wait. You said if you set... Oh, it's not worth trying to mess around to try to save a few clock cycles. We should be plenty fine in this function. Oh, hey Cleon. Stream's actually going really well. I'm just tired. I think I had like 3 hours of sleep last night, so it's been a little rough. Friday. No grabby chair. This is so annoying. This is gonna be a total, just flaming mess at first.
Does LB just like 0 extend?
Say what?
What does LB even do? It's load byte, right? So
Yeah.
does it 0 extend into the register?
I don't remember.
Or does it...
I think there's like there's two different variants of it.
Huh. I'll take a look. Yes, it does.
So for the CRC, what are we using this for? Does this 2 CRC mean...
So you could totally, with the CRC, you could pull the same trick as we do in the decode loop, where we specialize it for 0 and 1. For like, well, is this is the okay? This is the bit loop. Yeah, so you could totally do that, right? And then you can you send it afterwards, I guess. I don't know how this part of the protocol works. Alternatively, you could have the user send the CRC themselves, because too bad.
Nah. So one of the nice things is we will have free time, so we can just compute the CRC as we go.
Alright, and you can just, I guess, shove the existing code in for that.
Yeah.
It should literally just work. Assuming we have the temporaries for it.
Moving S0 and S1 into T0 and T1 was a bad idea. I should totally have, like, put that on the stack. Actually, I think I will put that on the stack. And I don't even have to think about it.
Sam was vindicated.
Say what?
Sam mentioned earlier, for a completely different reason, that he didn't like loading S0 and S1 into T0 and T1.
Yeah, okay. Yeah, because I don't want to think about running out of these values. And we're already out of the compressed ones, somehow.
Compressed is S0, S1, and A0 through A5, right?
Yeah.
Alright, I'm going to be right back for maybe 10-15 minutes or so.
Alright, that works.
Alright. Let's see them.
Thank you, Grilled Co. I don't know about how awesome I am. I'm trugging through this as fast as I can. I really would love to get this, like, doing something tonight. I don't care if it's, like, actually working, but if I can get it to, like, kind of half work, I will be more than happy. Ooh. Well, the CRC code looks uber cursed, but let's see how it goes. Friday is so adorable. It's like, it's so weird. Why is he looking at the camera like that? You're a good boy. Five. Friday looks adorably at the camera. How do you even spell adorably? Oh, good. Okay. Wait, what was this and? And, add, and. And, add. Oh, weird. Okay, I guess that's just how that works. The polynomial. Okay, that worked. T1. T1. Man, I wish we had an extra compressed register there. Okay. Oh my gosh, and we have to handle bit stuffing. Crud. I forgot about bit stuffing. Maybe sending is going to be as complicated as receiving. I'm not going to do that, like finish this on stream, I think. Okay. So that's the CRC. We have to figure out how to do bit stuffing. Oh, good call. Thank you, Michael. I messed that up. Actually, tell you what I'm going to do. I'm going to do a midstream push. That way you guys can look at the code. This is not post XOR. Well, you know, I might be willing to hold off on this until the next stream to make it go. I mean, I don't know. I'm going to keep going right now, but I don't think we're going to get this working. This is going to take a little bit more like sleeping on to make it good. I feel like I have maybe another 45 minutes left in me. Toucans. There are certain agreed upon times in which the host and client are allowed to talk. And the idea is that the host will never talk in the middle of a client talking. A client has up to 6.5 bit slices of time to respond to a host after the host sends it a message. The client will never send a message to the host unprompted. If there are 8-bit slices between when the host finishes sending a message and it receives no response, it will assume that the client is not going to be sending a message back. So in practicality, you basically never ever have a collision of the USB lines. Okay, so I'm going to make it so S1 contains LSB is last logical state, and bit 2 is last, bit 1 is last physical state. So if we send a 1-bit, I always forget this, a 1-bit is don't change, and then a 0-bit is do change. So 1 bit is key at the same. So we only want to look at the second bit, which is the physical state. So if it is a 1, last bit was a physical 0. And so for here, actually, before I forget, we want to what is it, T1? T1 is bit run length. Okay, so add I T1, T11. We might want to go the other way around. So add I T1, T1 minus 1. T1. You're a good boy. You're such a good boy. You're so good. You're a good boy. You're a good boy, Friday. Groko says, it's 1 a.m. Do you know if your child is programming in assembly?
I have returned.
And we're going to have to tune these branches so much.
Yeah, this looks like fun.
Cat beard? Oh, yeah, that does kind of look like a cat beard. You're so good, Friday. Yes. Oh, hello, person from Finland. Yeah, this is going along well. Full blast. Actually, this is kind of actually coming together, so you're a good boy, Friday. Can you hear him? Is that coming through? You're a good boy, Friday. Aww. Here, I'll aim this down a little bit. I guess I can't. I'll have to put this. There we go. Good boy. Okay. Was a physical 0. We're gonna do something to stuff a bunch of bits. I don't know. Something. We'll figure it out. We're gonna compute the CRC. I'd like to reuse this code if at all possible. Oh, actually, we totally can. Oh, that's cool. We could totally reuse this. Sorry that I'm not talking very much. I'm just thinking. In the poly function, what I'm going to be doing is I'm going to be moving the polynomial into the byte that we're going to be sending, and then I'm going to be saying we actually have like 5 bits left or something. And then we're going to go right back to going to the inner loop. Okay, this is not going to compile, but let's give it a shot. I can't think of anything else off the top of my head that I need to do. Whoa, that's a lot of errors. Okay, let's get moving. All right, I can definitely get my butt in gear when there's this many errors. Okay. Oh, isn't there like some problem with having no epilogue or prologue? Hi Friday and the rest. This is a good start of my morning and a new live stream to replay. Oh, thank you. Thankfully you're catching it live right now, Michael. Okay, let's give this a shot. How many errors are there going to be now? Lots of errors. Internal struct blah 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 is not defined. Yeah, I know, I changed the name of it. Boom. 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 Let's go fix that up in the .c file. Oh, there is a host. Oh, I guess that would be nice to track. I have to admit that. It'd be nice to know if we like have connected to a USB device or not.
That conditional jump magic, or that not conditional, the compressed jump magic you're doing at the end of those functions, if you ever have anything on like if you have a stack frame at all, that's gonna break.
Really?
Yeah, because you're basically just completely nuking the rest of the code gen after your after your function, right? So like stack frame teardown and all of that, right? I mean, I would literally just like return done USB message in or something if and yes, I think that works even with void.
Even with naked functions?
With naked functions? That's a good question. Yeah, I think so. Should just work. You're just calling it.
Let's just see if this works.
Because because naked is just telling the compiler don't generate any extra code around it. Wait, okay, hold on. You're doing C code? Oh, geez.
Well, the nice part is the C code can completely thrash all the registers. I couldn't care less. Like, I'm backing up the registers. This is the very last thing that's happening in the interrupt. I don't.
Yeah. No, I meant more like stack frame. I guess if you have no variables and okay, well, I guess if you're doing all of that, then the volatile assembly should work fine.
I'm just curious if it works. This probably is. Yeah. This is probably overly cursed, but
well, hey.
I mean, I guess what is the other way? I guess I could say set the return value to, and then like where I want all of the returns to go, like basically like a tail call optimization, and then
I mean I would just tail call it. I mean why not just call it at that point, right? Like
yeah, okay. Ooh, we get a free descriptor if we use ESP USB's thing. Let's do this. Spicy. Oh yes. This is a freebie from ESP USB. Maybe I should just do that. That's a decent thought. I really probably shouldn't do the most cursed thing first. This is just going to confuse other people too, and it's only going to save like 7 clock cycles. No, it might save more. I don't know. Because it doesn't have to worry about saving it. No, I'm not in the mood of making things as cursed as this right now. Okay, so what this is gonna, and then what I can do is instead of BQ, oh, no, I don't want to do that. I want to call. How does call ret work? Wait, what does no callee saved registers mean?
It turns off like any of the register save and restore logic, essentially.
Oh, well, that might be fine. Is that just an attribute?
Yeah, it's just an attribute. I don't know whether it's a thing in GCC. I would hope so. But yeah, no, you can literally just tell it, do not do this, please.
That is one heck of a long thing, though. Wow.
Yeah.
Okay, well, we'll just go with that. How do I prep this so I can just jump in? What does ret do?
I think ret is essentially just what, JLR RA or something like that. It's another pseudo instruction.
But what is it? JALLRA. What does the link do?
Oh, it's the link register thing. So it's God, instead of storing the return address on the stack, it's stored in a register. Well, that's a lie. It's ish. It's stored on the stack, but also in a register. It's weird.
I don't want it stored on the stack. Ret is JALR X0 X1 0. Oh, okay. Wait, so can I just do this? Can I just set my link, my RA? Can I just say LA RA and then this done USB message in, and then just branch to the function call?
From assembly?
Yeah.
Yeah, you should be able to.
Let's go with it. We're changing so many things right now. There are so many things in flight at the moment. Ooh, what is that mess? Is there some missing Unicode? What? No callie? Oh, there is something there. What is that? It's an invisible character. Ooh, it got further. No callie saved registers, directive attribute ignored. Darn it.
No, you should probably do it like on the function declaration itself.
I did.
Is that the one that was ignored?
Yes.
Oh. Let me just say this. Attribute direct. No, not sorry, the definition I meant, sorry. Like that should totally work fine. As long as yeah, like it has to be on the function definition. Like
Oh, this is weird. Well, can I do a no return?
Yeah, you can do no return. I don't know if that's a good idea, but you could.
Wow, this is going to confuse so many things. What is CE and what is EPS? Current endpoint and endpoints. Yeah, I guess we need those.
Yeah, I really wouldn't do the no return thing if I'm gonna be honest. That feels like GCC's gonna do some nasty things.
Oh, you mean like it could wreck up the stack pointer, which I don't want it to do.
It could do that, or it could, like, anytime that you call it from some specific location, it'll just, like, completely crap itself, or, like, it'll tell you right there, like, in some cases, because it implicitly assumes that it can never return, any type of return instruction that, or any type of return that you have inside of it is technically undefined behavior. Like, it's just not good. Because essentially the only time that's used is when it's like exceptions, basically. So like set jump, long jump, or like the program, like you know that the thing is gonna crash, right? So
okay, well, I'm just not gonna do it. So
yeah, exactly. Probably the best thing to do there, honestly.
okay, what is this? What is this? Empty packet. Wow. I feel like I could write this code better now. I am definitely like a few more years into this. But let's just keep going. What is this? Empty send buffer. I guess the other thing is that all of this, the old stack was written with what? Good grief. Okay. All of the stack was written with extensa in mind. Wow, that is evil. Why did I do that? What was I thinking? Let's just go with it. Okay. ETS memcopy. We're not using that because we have memcopy now. Okay.
I just saw what empty send buffer was defined as on the stream.
Yeah.
Yeah. Wow. That is certainly a design decision.
Sorry.
No, it's just funny.
I don't know if we ever used out messages, but I'm not really worried about that right now. S arrow. What? What is S? Huh?
S.
What is S?
You sure commenting out the line of code that you just commented out is a good idea?
Which one?
The one that like said CE as well.
Oh. Thank you. How you must be like a super elite coder to be able to read and like process things like that.
I mean, no, but it's one of those things where that type of code, how do I say this? You get reasonably good at recognizing that type of sort of bug-prone code, right? Where it's like when you do that sort of thing, yeah, it is reasonably tricky to parse at first glance, right? And so. Yeah, no, C is whack.
Descriptor list entries. Oh, now we're getting a little bit into the weeds. Okay, so we're gonna have to instance descriptors in the .c. We're going to have to say pound define. Wait, wrong thing. Not instance descriptors. Oh yeah, pound if and def instance descriptors. Yeah, that's it. Okay. Wait, pound if in def. What? If in def instance descriptors. Instance descriptors. They're right there. If it's not defined, then it will. If. Oh, if def. I can't read. Okay. Cannot initialize array of unsigned short from literal string with array type of int. 170. Ooh, we aren't ESP USB 2. We are RV03 USB. So string descriptor size of stir manufacturer. What's the problem? Cannot. So on 187.
Where is this? Where is the
stir manufacturer?
USB string descriptor struct. Oh, that's wacky.
Why
Maybe
is
try
that not
using
allowed?
WCART array.
What?
Maybe try using WCART array instead of UN16. Because that should work.
What is it?
WCAR_T.
Oh yeah, that.
Oh, but yeah.
Oh, that worked. Oh, I hate Unicode so much.
Yeah. Yeah.
USB handle custom control. We will need to write that eventually. .209. What's wrong with 209? Packet size. What? Oh, 290. Okay, well, what is the value? ETS mem copy and term. Alright, so now we have the obvious problem, which is if we're in assembly, this is not going to work. So What I'm going to say is pound if and def assembly. Wait. Huh? $27. But that's in the middle of the if and def assembly. Am I not pound defining assembly?
Is it underscore assembly underscore? Maybe?
Oh, assembler. Oh, is there actually a real assembler pound define?
There should be. Yeah. Hold on. I really hope so, at least. Kind of suck otherwise.
Can you look that up for me?
Yep.
Michael says, stop, you don't want to use wchar-t. That's not 16 bits there.
Oh, no, I mean, he might not...
4 bytes! No!
Yeah, no, that he's... okay, you want, I think, F short W cart T. No, should have listened to compiler.
No, I am not going to do F short W cart T. We're doing a UN16T, and we're going to make that, like, we're going to RAM jam it in there.
Yeah, no,
Thank you,
yeah,
Michael.
no, but I'm thinking that's what you would make it a UN16T, and then you need to do something to force GCC to... hold on. There's gotta be a way to do that. Yep. As long as you're...
Oh, no. There actually is a thing. It's char 16T.
That's relatively new, isn't it? I mean, yeah. That should work.
What? Who cared? What? Are you kidding? It's apparently too new.
Are you for real? Okay, hold on.
No, I do want to support strings. But I guess I could make them like the literal string of like backslash or C backslash 0, N backslash 0, L backslash 0.
Yeah, or just you. I mean, or you could use F short W car and break.
I am
all
not
third-party libraries.
using F short. Wait, it just worked. Apparently, you can use U and just use UN16Ts. Okay.
Okay, that works too. Sure.
Now we have to
Why
go
not?
fix the rest of our assembler messages. 316.
That works too. Thank you, Michael. That was dumb.
Yes,
I'm too used
indeed.
to Windows land, where WCAR-T is 16 bits. That...
Wait, are you not allowed to use 0B in assembler? I think you aren't allowed to use 0B in assembler.
That is unfortunate.
Or not? No, something's hosey.
Ah, yes, I was right. It is underscore underscore assembly underscore underscore. These are the fancy MINAS or not macro.
Well, I will do that right now. That did not work.
Okay, great, fantastic.
So you said it was underscore underscore assembly or assembler?
Assembly with a Y.
Yeah.
And all caps.
Oh. Nope, still didn't work.
Alright. Well. Guess this thing is lying to me then. Okay. Well, that's fine then. You can...
Was it ChatGPT?
No.
Okay,
no,
thank
no,
you.
This was
I want
GCC.
this to be like sport. I like these to be like sports.
No. This is
Okay. No ChatGPT
this is
helping.
real documentation getting things wrong apparently. Awesome. Wait, what? If GCC is wait, what? No. GCC predefined macro assembler. Oh my god. Okay. What? So Linux uses __assembly __, and they hard-code a define for it themselves. But GCC defines assembler, apparently. Not according to ChatGPT still. I promise you.
Wait, so what was the thing I should do then?
Assembler instead of assembly.
Oh,
And
I see your
assembly
message
is-
now.
Yeah, and then...
Oh, snap. Something just exploded. I don't think that's right
That's
either.
fine. Are you kidding? GCC documentation is lying to me.
Oh, no. It's because I copy and pasted from YouTube. There was like an extra invisible
Ah.
character. Still
That'll
wrong,
do it.
though. Still wrong. If and def assembler. ASSEMBLER.
And this is all caps, I suppose? Yep. Okay.
Yep.
Excellent. Fantastic. GCC docs are lying to me. Great. Okay. That's fine, though. If it works, it works.
Oh, wait. No, this is not there. This is a different place. This is in Siege32V003 Fun. Oh, so maybe it is good. Maybe that is it.
Oh, okay. Well, that's good.
Hey, that was it. That was it. That was it. That
Okay,
was
good.
it. It is
Okay, so
assembler.
GCC docs are not incorrect, as it turns out. That's always good.
Oh, wait, maybe... What is going on? Oh, I have to get it in all the places.
Oh, because
All right, that worked. Okay, moving on. Now we're down to 330, c.add some awful thing, and then, yeah, it was the annoying part about 0x, and then that's b4, and then this one is 0x, b4, minus 0x87, and then this one is going to be 0x87, and this one is 0x96. Gosh, I'm so glad I can read read binary. I don't know when that happened in my life, but whenever it did, man, that was a whole new world. C3. This one is 0xC3. This is 0xB2. Wait, B. That's not B2. 8, 9, 10, CD. Oh, D2. Okay. Let's give this a shot. No. Why? operands. Oh, A4, A4. Well, let me make sure I'm not crazy. Let me try to put the binary back in. Oh, no, we are allowed to use binary. Durr. It's just that the binary, or these numbers don't fit in the compressed instructions.
That is unfortunate.
But excusable.
Oh, well.
Wait, how does that not fit? That's not that big of a... Nah, whatever. Okay, fine. Add I, A4.
What are the limits here anyway?
Add
Question.
Oh, I just realized something else fun. For those types, we could just nerf out the top couple bits or something. Hold on. No, we could still do this.
Good. What assembly is this? risc-v 32E. Yeah.
So it's 1101. So setup is 1101. What we really should do is just c dot r wait, what is it? Rotate. I can't remember the shift. Oh, sorry, li. A4.
No rotation, no surrender.
Oh, this is so much better. Oh, actually, this is even better. For a 4, 4. Oh, that's so much better. Four, 1, 3. We got through those errors. Yeah, we're not going to use compressed load there. I got that. 414. Oh, why not? Why can't we do that? A1, A5, outdoor offset. Why is that not valid? Is that too far?
Yeah, could very well absolutely just be too far.
Also, we aren't using outdoor, right? We're using BSHRC.
Yeah.
Or BSHR. Oh, okay. That apparently wasn't too far. Now we're down to 424. Store word S1 Sculver say 5. Illegal operands. What happens if I just put a C in front? Oh, it didn't like that either. Oh, it's because CFGLR is not like a thing. It's like a different thing. Yeah, thank you, Michael.
Yeah, I was about to say you might want CFGLR offset there, right?
Okay, so 427 is... Yeah, that is not going to happen in a C command. Okay, 431. Okay. Wait, is C.lb not valid here? Wait, is c.lb not a thing?
I was about to ask, is that even a... Well, it is using the fancy... If I recall correctly, this was one of their, you know, proprietary extensions that we know literally nothing about.
Oh, you're right. It is one of those extensions.
So
I want to use
for all
it.
intents and purposes.
I don't want to use it. I'm not going to use it because I don't know enough about it right now.
Yeah, for all intents and purposes, the answer is no, I guess.
I'm going to just say replace me with the special opcode. So what is it? It's not LB, right? It's something else. Load by...
It was something insane. I mean, I think it was literally c.lb. Or unless you mean the...
No, the special opcode is really weird. It's like c.f or c.fl... It was like c.flwsp or something weird, which I really don't want to use right now. That's too cursed.
You're right.
What I want is to find... Here it is. Load... It's LB is what it is. Yeah, it's just LB. Oh, okay, that's fine. 453 now. C.ori. That should be fine. Is ori not... Oh, that's right. That was weird, right? Because there was like no c.ori, right? Yeah, there's no c.ori for some stupid reason.
Yeah, there's c.andi, and that's it. That's all you get. I think there's no zori either. I don't think.
Yeah, I think you're correct.
Yeah.
Oh, I'm sure there's a faster way to do this. I just want to find out if we're going to be even close to meeting the timing. 459. Yeah, I know. We're not going to go that. That's fine. 460. Oh, A1. No, wait, not A1. Last bit was a physical 0. What we want to look at is A3. Then 472. Load next byte. Oh, A3. Yeah. Whoa, now we're on to the linker errors. Okay. USB send data unreferenced. Is it like global? I think we use .global, right? That's a thing.
Yeah. If you want to, what, export, import, one of the two. Yeah, import, I guess.
No, I think it's for both, because those are our imported ones.
Yeah,
and that was it.
Yeah.
Okay, the next one is USB port base, which I thought we defined, but maybe...
Maybe it doesn't think it's a define.
Where in the world is that referenced?
USB GPIO base.
34. Oh well.
Yeah,
No,
I don't know what USB GPIO base is, but
well, that's like this thing I made over here, which is just the USB port. Oh, yeah, USB port underscore base. Is that not how you do gluing? I think that's how you do gluing.
The other one has to be defined as well, right? Like, no. The magic gluing, if you do something like that, I think it has to be like a macro argument.
Oh, yeah. Sure, we'll just do that for now. Okay, undefined reference to done USB message. What is that? Done USB message. Done USB message. Done USB message. Is this in the send code? No. What is the difference between done USB message and done USB message in? I'm gonna just YOLO this one.
Where is done USB message reference that it's causing a linker error?
I'm not sure, but it compiled, so let's just roll with it.
Oh, good. Because done USB message is the end of your interrupt routine, if I recall correctly.
Please tell me we got a message. Okay, we did. Hey, it didn't crash. That's cool. Actually, that's really cool that it didn't crash. Oh, wow. It didn't work, but it didn't crash, so.
Excellent start.
Okay, well, I'm going to go check the code in right now because we're in a decent place. Midstream check-in, code compiles. Okay. That definitely compiles. I'm going to LA-A5 debug value. Actually, I'm going to do test memory. Store word A4 0 A5. Okay. Man, I'm totally gonna have to go back with another. Oh, let me clean all. Gonna have to go back with another whack and reduce the memory footprint of all of this, because the goal is still to make this work inside of the Shush. Why is... Okay. 231 OOB. Well, that's a very weird... What? Oh, there we go. Nope. Nope, it's just confused. Load word. No, I really want to load byte here. Oh, I don't want to load byte here. Do I? I think I do. Oh, what in the world is this thing thinking?
Are your arguments correct to your various functions? Like, is the ABI set up correctly there?
Not worried about that right now. I just want to know why when I write this number out, it's something janky. Let's see if I write like it out here if it's better. Okay, so that it is actually telling me the value of A4. Let's look at the value of A0. The store work? No. Why? No, I don't want it to. Oh.
Is it sign extending?
I think so.
Maybe try LUV? I don't know. No idea. LBU is load byte unsigned.
Well, I still want to do the curse thing. Actually, yeah, I could just do LBU. You're right. LBU. Then I could do that. And then it becomes this. Let's make sure the ACK packet is what we think it is. Yes. Because all of our packets are backwards. Oh, SRLI. Zero 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 C. What is C? C is data 0. Well, that's pretty cool. Okay. So let's make sure that this is still sane. So A0, A4. Oh, we want to remove that. Okay. So I think this might might just work. Darn. B. What is B? One, 0, 1, 1. So it's counting from this direction going back. That makes no sense. That shouldn't be possible. A4, A0, A0, A0. 4, A0. What? Eight. What in the world? There's no 8. Oh, I guess that's an outdoor. No.
Just as an FYI, I don't think your setup packet check is because you're doing the sub-I at the top for the ACK packet. I don't know whether you're accounting for that below. Maybe I'm missing something.
No, up here I'm A4 minus blah 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 blah. Here I'm reloading A4 from A0.
Okay. I missed that line then. Yeah, sorry. Yep.
C. That is definitely a data packet. Oh, maybe on the data packets we're failing the CRC somehow. No, we're still getting those data packets through. So branch equal to 0 is data. No, it's branch not equal to 0. B N E Z. Okay, let's give this a shot. I'm gonna just hole-in-one this. Absolutely. MLG, all 420 no scope. 360 no scope. I don't know. We'll see.
420 no scope. Yeah.
Oh, we're still not sending anything back. Darn.
Oh.
Oh, and something got mega hosed. We like crashed.
Oh.
We bit dirt.
Well, if you're actually calling the C functions are probably cooked because of ABI.
What do you mean cooked?
Like, I don't know if you're setting up the registers correctly there.
I think I was. It's really simple.
Yeah, it should be A0, A1, A2. I think, assuming USB PID had, if I recall correctly, it had 3 arguments. Maybe I'm...
I mean, I'm not really sure here, but it looks like maybe we called the... Maybe we called the...
Yellow.
Oh, people are saying things. risc-v, it looks very clear. CFGLR offset, linker errors. Can somebody explain what he is doing? Oh, heck. No. I am writing a bit-banged USB stack for a 10-cent microcontroller so that I can use USB on this little itty-bitty black processor in the middle that's out of focus. Oh, actually, you can see it over here. It's on the side. It's this window. Okay. Well, let's see here. What would happen? So, branch EQ 0, PID handle data. Man, I really love the idea of being able to tail call back here, but is this what's breaking it, I wonder?
Good question. Hold on. What is USB PID? Hold on. You pushed something up, if I recall correctly.
Oh, I just realized something. No, this does need to be a load word. A0, because we use that later. Oh.
Good.
Oh.
A0, A1. What is this token in your USB PID functions? I'm assuming that's supposed to be like the actual. Yeah, okay.
Okay, well, it's not crashing anymore.
That's a great start.
Let's see. What is the value of A4 here? 8.
I mean,
So that's an out. That's not right. That is not right at all. Oh yeah. Well, it's 8 plus that. So, or 1 plus that. Yeah, 8, 8, 4, 6, C. So it's C. Here it is C. I have to add this back here. Dang it. Add I, A4, that. Okay, well, we'll undo this. Oh, we could do A0 here.
your code didn't compile, by the way.
I know. I'm going back and fixing this.
Oh, no.
Well, it didn't crash again, but it didn't work. What is it? Oh, it's not outputting anything. Darn it.
Let's see how far you got. Or is it just breaking on the first setup packet, I guess, because it's not sending anything?
hey, hi. Oh, okay. I'm gonna have to go in a minute. Oh, hold on. Give me just a minute to. I think I'm basically. I don't know. Sorry, guys. I'm gonna have to go in a minute.
No, it's okay. I'm not in a rush.
You sure?
Yeah.
How late are you gonna stay up?
I might just end up staying up until my flight.
Oh, really? Wait, when's your flight?
It's like 6 p.m. I might nap or something. I don't know.
Okay. I don't know. I mean, I got maybe another half an hour in me. I don't know. Maybe probably not even that. Maybe like 20 minutes.
Yeah,
What I really want to do is at least be able to like. I want to see this thing try to send a message out. Like that's my goal. So let's see here. So A4 into. Yeah, sorry. I thought that I didn't see your message earlier, so I was still streaming. Anyway.
That's okay.
A5 test memory. A4 A5. Why is it crashing? Handle data. Let's just run the debugger.
Get in. Little mouse with cheese.
So it's in the printf. It should be able to go. What? Why is it not working? Okay, night, Cleon. Sleep well. Oh, hey, it's somewhere. Send one. Okay, we're talking. This is inside of the send code. It's actually going to try to send it. Let's take a look. 482. I just want to see a line get twiddled, and then I'm gonna go to bed, or at least log off or something. 482. Send 1 bit. Yeah, that's pretty far. T1 minus 1. Wait.
Oh, wait, no.
I should have written more documentation while I was writing this. But this is like branch not equal to 0. This is like... Oh wait, so no, it's if I XOR, it's when it means that last is different from this. That means we send a 0 bit. So if it's 1, yeah, no, I think it is. But if this is 0 and 0, that's a 0.
I think that CRC code.
This
I don't
here?
know what
No.
specifically it's doing, but it's also clobbering A3, and I don't know whether that's.
Ooh, good point. That's a very good point. Oh wait, that's the wrong window. We don't need this anymore.
I also don't think you're ever actually sending 1-bits. If I'm reading this correctly.
Well, I mean,
But-
a 1-bit just means you don't change.
Oh, right, yeah, right, okay. Yeah, right. Fancy schmancy encoding.
Scratching again.
Oh no. I did give him a full shampoo. Hopefully they give up. Anyway, I don't know. I just wanted to do something. Like, literally anything. I'm gonna just try this and see what happens. Nothing. It didn't work. I think the problem is up here. Oh, man. Friday's going nuts.
Give it back. Give.
Let's just go look at the CFG LAR one more time. Output mode. And this is +2, so here. This will be inverted, so these will be 0, 0. Universal push-pull output mode. This is 1, 0. It is not inverted. That is output mode, maximum speed 2 megahertz. Let's try it the other way. Let's try 10. 0, 1. 0, 1. Actually, tell you what. Let's just output this. ×4 USB. Oh my gosh. Maybe that's it.
I found a way to get Friday to make biscuits.
Make what?
Make biscuits. Where they like knead.
I have never heard that called making biscuits.
What do you call it?
Kneading.
Making biscuits.
I've only ever heard it called kneading.
No, making biscuits. It's like kneading dough.
Okay. Is it gonna do anything at all? It did literally nothing. I don't know, guys.
Ooh,
It's 5 hours, 24 minutes. I'm giving myself 5 minutes and 15 seconds left to do this.
Do you want Mr. Cheese? Mr. Cheeses? There you go. Look at him. Mr. Cheese. It's not easy being cheesy.
Mr. Cheese?
Mr. Cheese, the little rat. He's holding
Oh. They're all zeros. Why is this 0? Michael, I did get both instances with that fix. Or all instances. We can just do this the other way, which is
What's the goal with the bitwise and there? Like and.
Well, I'm changing it. I'm gonna do something a little bit different.
All right.
So now I'm doing it like the traditional way people. I don't know what I was thinking when I did it the other way. Okay, well, I think we're still crashing in the middle of all of this, but let's just see if we have anything being driven. Dang it. Oh. Well, that's special. That's really special, actually. I think what's going on is it's clamping the line. Yeah, that looks like it's clamping. I did not mean to click that, but... Oh yeah, it's clamping the line.
Oh. Got it.
Well, this is good enough for me. For tonight right now. Thank you everybody for coming out. It has been fun again. I will likely, I don't know, I might be able to stave off the desire to do any work before the next live stream. I think we are really close to being able to have this thing enumerate over USB. And I don't want to let you guys down by exciting and being all happy on my own. Thank you for coming out, and yeah, have a great evening, everyone, and I'm gonna see you all soon whenever I get around to finishing this project. Hopefully either like early next week. Have a great day, everyone.
Bye.
Bye.
And thank you, Duck. You've been a huge help.
Absolutely, no problem, man.
Oh, let me check all this in. End of stream. We're driving the line. It's just clamping.